the latest workshop that we are hosting in the build up to the ATN Summit. We have another incredible workshop lined up, which is totally free for you guys to come and join and watch. I always like to take a second till I can see myself, make sure that I'm live. But whilst I do that, one of the things I always love to know is where you guys are from. So please put in the chat where you're tuning in from, what city, what country. We always like to hear that. And also let me know if you can hear a crazy echo, because we had a problem with the last one, but it should be fixed now. So things are all good. Yeah, put in the comments where you're tuning in from. We always love to see where you guys are calling in from. There's already a few. Oh, first one out of the gate, Cairo, Egypt. Incredible. Mexico, Ethiopia, Vietnam, Argentina. I mean, we're already pretty much covered the globe already. Sweden, that's good. We got a Swedish house mafia are in the house today. Ethiopia, Brazil, amazing. Yeah, I always love to see it. I mean, that's why we started an online platform. Is we could do this in the classroom with like 30, 40 people, but now we're doing it online. Guatemala, Yemen, South Korea, Chile, Brazil. I mean, we're pretty much ticking off every country there is. Of course, this workshop is part of the build up to our event. So if you guys don't know, we are putting on our very first big boy conference, I would call it. It's called the ATN Summit. It's a 2-day conference here in London, where we're gathering an incredible lineup of speakers, sponsors, innovators, tech companies, influencers will be there to have a 2-day event of talks, networking, and all this different kind of stuff. And we're doing kind of TED style talks. So they're like 20 to 25-minute talks to talk about everything to do with architecture, technology, and innovation. Tickets are on sale now. You can check them out. We're now in the last phase of the ticket sale. You can grab them now up to, in fact, it's not the main ticket sale, it's the final ticket sale, up till the 17th of March. And the great thing is we haven't increased the price because we've kind of hit targets. So we're maintaining this price point. If you can't attend, the talks will be recorded and they will be available sometime after on our website. So go and check that out. But enough of promo stuff. Let's get into the juicy workshop itself. So today we have a workshop with Finch and KPF. And this is one I'm actually been looking forward to myself. I know KPF have a great history of computational design. They do all these incredible products, skyscraper products around the world. They have a really great computational team. And Finch is one of these companies that's really been doing some amazing things with computational design, AI, automation. At the moment, they're focusing on kind of automating floor plan layouts and stuff like that. But it's becoming a tool that I see more and more practices using. So today we'll find out a little bit more about how KPF are doing it and how Finch are being integrated into KPF's workflow. So you'll get a little bit of both sides of the coin, a little bit of computational design from KPF, and then also learn the basics of Finch. But without any further ado, I think this is a perfect time to bring on stage our tutors for today. So I think the first one I'll bring on stage, since he's solo from KPF, is Mikhail, who is tuning in from the London office. He's associate principal at KPF London. Let me bring him onto stage.
Hi.
Mikhail, how you doing?
I'm great. How are you doing?
Good. I'm happy. The crazy echo is gone from the last episode, so touch wood, we're flying. Thank you for joining in. We're excited to see what you guys have. Mikhail has also shared some files for you guys to get going. It's in the comments. It's also in the description below this video. You'll be able to download the file. It's a little zip file with some Rhino and Grasshopper files in there. so you can jump into that. Next, let's bring our other guests on who someone put in the chat they're tuning in from Sweden. Well, we have a couple guys from Sweden. We have Jesper and Ruben tuning in from Sweden. Jesper, of course, is one of the co-founders of Finch, and Ruben is one of the kind of customer success managers. So I guess if you tune in and start using Finch, you're probably going to run into Ruben and Jesper, to be fair. Guys, thank you for coming.
Thanks for having us. Looking forward
Thank you.
to the workshop.
Yeah, great to be here.
We have a nice and even split here. We've got London on this side, Sweden on this side. We have a few people tuning in from Sweden as well. Some more people putting some stuff in Kazakhstan, Ethiopia, Colombia. It's always really amazing to see where people tune in for this kind of stuff. A little bit of housekeeping. So for those of you who are listening in, if you have questions, please do put them in the comments. I will track all the questions whilst the guys are kind of demoing and screen sharing things. I will pick them out, and we'll also have a little break in between where we can also address any questions that you have. Maybe to kick things off, I don't know, it might be nice just to talk around a little bit about your roles in KPF and Finch. So, Mikhail, do you want to talk a little bit about your role, your background in computation, and just give us a bit of an overview?
Absolutely. So my name is Michał Ścigaj. I'm Associate Principal at KPF. I'm also a computation design lead. So that makes me sort of on two different sides of the world. One is the architect, and the second one is being sort of design technology oriented. At KPF, obviously, I'm focusing on larger objects, towers, master plans, airports. I'm senior architect of those projects, leading the design. So I kind of grasp the basic of architecture design. But on the other hand, I'm also focusing on computation designing, as I mentioned, coding, a bit of machine learning. Generally, I'm trying to, use computation design not only to generate complex forms, but also to kind of enhance productivity and allow architects to spend more time on designing rather than doing repetitive things. And this is what I will try to focus on today during the workshop.
Awesome. Yeah, excited to see it. Jesper, give us a little bit of overview. Many people probably know you already, but yeah.
Yeah, my name is Jesper. I'm also an architect here at Finch. I'm one of the founders. I started the company, and my role here is that I'm in charge of the product and the algorithms. So I usually say that I'm between the developers that actually writes the code and the customers and sales and so on that interact with the product. So that's what I'm doing on my days here in Finch.
Yeah, I think just like Jesper and Michał, I'm also an architect that perhaps has different hats for different roles. As you said, I'm running customer success here at Finch, so I think I use my experience, my last decade of working with architecture to help with project consultations and just helping people get started, test out new projects in Finch. And yeah, at the same time, I think just like Jesper, also working with our development team here to help improve our product.
Nice. And how do you find as a Brit living in Sweden? Is it good? Good
Well,
mix?
the sun has finally re-emerged after I think we've had 4 years of winter. It feels so. Yeah, that's that's pretty nice.
It's
But
the
no,
same in here. Don't worry. It's the same in here.
I do
We just bet.
sometimes. Go
We
ahead.
just bet a record of 50 days of rain, continuous rain in London for everyone who lives anywhere else than London. Just to let you know, it was record even for UK. So
Which is saying something. All right, guys. There's one question in the chat. Can we save a Rhino 7 version of the file? I'll do that in the background, and I'll upload that to the link for you guys. But otherwise, you'll just have to roll with the files we have. Don't forget, this is recorded, so if you miss something, you can go back. We'll just leave it on YouTube, so you can kind of go back and forth and pick things up at your own pace if you miss things. But it is encouraged to try it out. give it a go. Take a picture of it, post it on Instagram or LinkedIn, and tag us. And we always like to see what you guys create. But I think this is the time now to hand over to Mikhail, who's going to first kick things off, and then it's basically a game of two halves. We'll hand it over to KPF, and then we'll have a little break, and then we'll hand it over to the Finch guys. But Mikhail, if you want to share your screen, I'll hand it over to you.
Perfect, thank you, Ollie. Just to add to what Ollie mentioned about the files, you can find two different files in the link. Let me just quickly share the screen first, maybe. I can't do two things at the same time. So, okay. All right. Can you see my screen?
Yeah, it's all good.
All good. So to add a little bit about the files. So in the link, you will find two files. One is Rhino file, which is the base file we're going to use for development of this Grasshopper script. And you also will find Grasshopper file, which is the finished version of what we're going to build today. So whenever you feel like you don't know what's happening, or you kind of got lost, or maybe you made a mistake, just go back to the finished script and probably you'll be able to figure out what's happening. Additionally, the workshop is built based on Rhino 8, sorry, but I will actually show you how to use Rhino 7 as well. So I will give you a little bit of time to download everything and set up everything. Actually, you should also probably download Finch, which you can find in Package Manager inside Rhino. But that will come later, so you have lots of time for that. So while you're downloading, I'm going to talk a little bit about KPF. It's actually very special year for KPF because it's company's 50th birthday. And in the last 50 years, the company managed to grow and spread pretty much across the whole universe, having its offices in all major locations. KPF believe in power of urban architecture and its strength to transform cities. Impact of this urban architecture on neighborhoods, but also the impact of neighborhoods on the projects we work on. So we really focus a lot on the context. Additionally, we really trying to create innovative architecture, innovative design that is surrounded and surrounded with crafted details. Probably some of you might know that we specialize in towers, but not only, but towers is one of our main things. And 6 out of 12, the tallest buildings right now in the world are actually designed by KPF. But as I mentioned, towers is not the only thing we're doing. We also love doing master plans, obviously full scope of architecture, interior design, applied technology, environmental modeling. In terms of sectors, we work across almost all sectors, starting from residential, office, hospitality, education, mixed use, research, and laboratories. So this is a couple of, our, let's put it, probably some of the most famous projects that probably from the world. I'm talking about Hudson Yards, One Vanderbilt, the new Abu Dhabi airport, or for example, the Atlantis de Royal in Dubai. It's quite interesting to know that Covent Garden in London was also the master plan behind Covent Garden in London was done by KPF, and many little projects around this master plan are also by KPF. So a little bit about the subject of the workshop. We can see that we probably all know that the clients require architects and probably all designers in the process of development of the building to accelerate and deliver things faster. Sometimes, or almost all the time these days, we are noticing that the gaps between different stages slowly disappear. Quite often we end up delivering almost SD design while submitting concept design. So technology is a very good tool to accelerate the way you work, starting from speeding up the decisions, speeding up validation, and speeding up possibility to change things. As we all know, changes are happening all the time in our industry, and in the process of developing a building, we have to change it all the time. So having something that actually allows you to make those things quickly, like a Grasshopper script that we're going to talk about, is something that is very useful to have. So talking a little bit about what we're going to build, let's maybe have a look at finished script for a quick moment. So this is the final outcome of it. It's a very generic piece of a city, piece of it's pretty much massing. What that it does, if we look at the base of it, you see it. We have a couple of center lines. Those are setting out lines we're going to use to develop the model. And whenever we do any changes to those lines, we move them on sides, we twist them, the model will adjust to the new geometry. And what is also very important is that if you scale this, meaning if you expand the setting out, let me turn this off for a second. If you make everything larger or copy paste literally the same setting out, you can populate it as long as your computer is able to calculate everything on time. But you can make it fairly large. Trust me, we tested it. Additionally, so what we have here, we have roads. We will generate some sidewalks. We'll generate parcels. We'll generate also buildings, very generic buildings, but probably that's something that's quite commonly used when you develop master plans, meaning some sort of low-rise and towers. And all of those will have tags which will inform you how much area you have per given building. All right, so looking at this, I'm hoping that you guys already are ready and you have your Rhino files open. Please open completely new Grasshopper file. I already have one prepared right here. And let's zoom in at the setting out lines for a second. I will maybe sketch over to explain you what we're going to do first. So when we actually do all those things step by step, you understand where we're heading to. So we're going to start from actually generating roads, which will be offsets of those lines. And then we'll connect those lines into one outline. And this way we're going to get parcels. Once we have parcels, we'll obviously divide everything nicely. So we have surface of a road, surface of the sidewalk, surface of the parcel. And on top of it, we're going to create also buildings, as you could see in the preview I was showing you earlier, with some sort of towers in the corners, located as far as possible in each parcel, so there is limited overlooking happening. All right, so having this in mind, let's maybe start developing the script. Oops, not here, this way. So what we're going to start from, and so for those who are using actually Rhino 8, or maybe let's start from Rhino 7. So for those who are using Rhino 7, you will have to probably follow old way of doing things, meaning grabbing curve component, curve nodes, right click on it, and set objects which are on given layers. So whenever I will try to pull out some things from given layer, you'll have to do it manually. For those who are using Rhino 8, we will use technique which allows those picking up those lines from the layers by Grasshopper to happen automatically, because this is what we generally would like to do. Like if I suddenly copy this line here and that one over there, it should read it automatically and recalculate the whole script and generate the model again in a new form. So we'll follow the Rhino 8 way of doing things, meaning firstly, we need to find those lines, and those lines are located actually on the layers right here. we have layer responsible for primary roads, secondary roads, which are right here, tertiary roads, which are right here, and we have also residential paths. Whoops, yeah, marked correctly. We also have heights. We have two types of heights: heights that control high-rise and low-rise, and those will also move around to kind of play with them and see what will happen. So for now, let's focus on bringing maybe those roads to Grasshopper. So Grasshopper sees everything that's happening inside our Rhino canvas. So the first step is copying our parent layer, parent's layer name, and putting it inside panel. Then let's grab the first layer of the name of the first layer, child layer inside KPF center lines. And let's create another panel with it. Once we have that, let's use concatenate. Let's connect those things into concatenate. And then let's see what we actually have in here by using panel. So you see, like, we generating some path, but this path still is missing double colon, which is necessary for Grasshopper to read the location. So we're going to add it by right-clicking on concatenate, separator, double colon, commit changes. So this way we have a path that is readable by Rhino 8 embedded already inside Grasshopper Rhino 8 component, which wasn't available in Rhino 7. That's why I was showing a different way of doing this at the very beginning. And I'm talking about query model objects. So when we actually connect it to this node, and we connect it to the panel, you see that we actually managed to get the IDs of the lines on 01-primary primarily layer. So this is still not lines. Lines will be actually collected when we connect it to curve component, and now you can see the preview visible on the left side. I'm going to actually click this yellow cylinder in the right corner. What it does is it previews the objects which are marked on the Grasshopper canvas. That helps a lot when you have many things happening in your canvas and you want to see only the thing you're actually working on. So I'm always having this one on, actually. So the first thing, as you remember, for what I mentioned at the very beginning, was to kind of create offsets on both sides of the center lines. Let's do that. Let's use offsets. And actually, if we have the road, which is, let's say, let's create firstly number slider from 10 to 30. I think that should be big enough. Yeah, let's keep it like that. If the road is, let's say, 20 meters, so actually when we offset this curve, we want actually half of this distance. So let's divide, let's use actually division. Let's divide this number by 2. Oops, let's try again. Here we go. So now we have 10 in here, and let's plug it into our offset curve component. So we got the offset on one side. Now we need to flip it to the other side. So let's copy it, and let's add negative node code negative here. Perfect. So if you look at our canvas for a second, you can see that we generated very simple outlines of the road. Now let's go back to Grasshopper and actually turn this into some sort of surfaces. So we're going to do it by merge. Let's merge those two lines. I mean, two nodes, technically. There are many lines in them, inside them. And then let's loft it. So now, once it's lofted, it generated surfaces out of each center line, which is actually the road. What we're missing still is obviously pavements and parcels, what we're going to get there soon. Once you got your lofts, let's flatten this. And then we're going to go to the tab called Intersect. And we're going to grab Region Union. Why I'm using Region Union? Because now we have one outline that all those actual surfaces we just created are sort of merged into one big outline. And this is exactly what we wanted to achieve. So this is great. So now we want to do the same exercise with all the other layers. So if I move it to the side for a second, we can remove that now. Let's make it a bit cleaner. As you can see, I'm a little bit obsessive about how clean your script is, because the biggest trouble happens when you do a very messy script and somebody comes and suddenly takes over your work and nobody knows what's happening in it. So I'm trying to be very clean whenever I do anything. So I'm grabbing all those things we just created and I'm going to copy it. Let's copy it maybe 4 times because we have 4 different types of layers. So 4 times. And the only thing we will change in each of those, let's call them inputs, is the name of that layer in here. So instead of primary, we're going to do secondary. In here, we're going to do tertiary. And residential paths will go here. Oops. Let's try again. Great. Perfect. I would also actually turn off the preview. Just in case you turn this button, the green button off and everything shows up, it can slow Grasshopper a lot. So great. So this is our input. Let's call it input. So remember and we know what is where. Inputs, let's make it larger. Let's say 50 should be big enough. This is our input. Great. Let's now focus on creating the parcels and pavement sidewalks, right? So how are we going to do this? We will have to merge again all those lines. Let's do it as we did with Region Union. Great. Let's flatten it in here just in case. Everything needs to be flattened. And let's add this one here. Perfect. Let's leave you off. Okay, so if we look at what we have here, actually, you realize that we generated pretty much what we discussed earlier, right? The outlines, which are now creating parcels, streets. Technically, what we have on the screen is parcels and some huge outline, which we don't need at this stage. So let's get rid of it. How are we going to do this? We're going to actually sort all those outlines by their area, meaning the smallest outline will be at the bottom of the list, and the largest outline will be at the top of the list. Let's do that. So we're going to use area component, and then we're going to use sort component. And this way, if I just do a check, let's check what's going on. Let's use list item component. List item outputs the first item in the list, or any actually, depending on how you set up the index, but the default is 0, meaning the first one. So this is the smallest outline. And if I right click on values A in sort and click reverse, it's going to grab the largest, which is exactly what we want to do. Perfect. All right, so at the moment we're grabbing the largest, but we actually want to remove the largest, right? So how we're gonna do this? Let's use cool index. And a cool index does opposite to list item. It removes the item on given item location. Let's put it this way. So we want to remove item number 0 in this case, which is the largest. Let's plug it here, and let's plug this one there. Great. So now we have only parcels, which is perfect. This is exactly what we need to do. Let's forget about this one, this big outline for a couple of minutes. We'll come back to it. So keep it in mind. We have it here. But we want to focus on parcels first and generate all the sidewalks, bring also residential paths, bring also tertiary roads, which are technically kind of back of house roads. So what's specific about those remaining roads in here? Tertiary roads is technically some sort of back of house road. This road doesn't need any pavements, sidewalks. It's just a pure road, fairly narrow. And oh, I forgot to actually change dimensions of those roads. So we'll do it in a second. So looking at the script as a whole now, this is where we should be. We have the inputs, we have our parcels right there. Let's maybe change the sizes of the roads depending on their priority. So as you remember, going back to the inputs, we gave 20 meters to the primary roads. Let's give 50 meters to secondary and 12 maybe 12 to the tertiary roads, back of house roads, and 10 to residential paths. Maybe let's do 8. So why not? Kind of more happy with 8. That is great. So now if we look at the parcels, we can clearly see that we have wider roads and narrower roads. Great. All right, let's move on. Let's move on further. So what we're gonna do next is grafting. And why we want to graph? Because we're gonna bring those back of house roads, and we want those back of house roads to impact every single parcel. And to do so, grafting is something that is necessary, unfortunately. So let's do grafts here. I also actually gonna right click on this component and change the wire display to faint. And why I'm doing this, so I'm kind of, again, it's about the readability of the script. I want to kind of indicate that this is some sort of completely new operation happening compared to this input, and probably we should have one more faint line in here. Okay, so this way, let's turn preview off. This way we have very clean script. Great. Let's bring those back of house roads. I will do it by firstly placing surface component. Again, for readability, I'll just place it like here, wire, faint, so that when you check the script, you see this is sort of the same level of operation. I don't know how to put it, but it's just easier to read it that way. And then let's move it closer to our parcels. So to kind of remove this road from parcel area, we're gonna go again to intersect, and we're gonna use region difference. So region difference works almost like Boolean difference in Rhino. You have one object that you use to remove something from the other object. So we want from parcels to remove our back of house roads. And as a result, you can see that original parcels look like this. Now we have roads without those, which is perfect. Okay. Where we are right now. Okay. So this is these are not actually parcels. I would say these are the edges of the sidewalk. To actually have the exact edge of the parcel, we need to make some space for the sidewalk. So technically, we need to offset this line inwards by 3 meters. So let's do that as well. Here. And we actually will do it here because, as I mentioned, we don't want sidewalks in back of house roads. So let's do number slider from 0 to 10, and let's set it up to maybe 3. Okay, so this is the line we had before, and this is going in opposite direction we would like it to go. So let's use negative node. Okay, it's going inwards. Generally, also, I prefer to offset things inwards because when you make lines larger, the outline of the line, when it gets larger by offset, let's do it again so I can show you what's the issue. So now, as you can see, the new outline is actually larger than the base line, the input line. When we explode this offset line, it like the offset created those weird extensions that you can find in here. And generally, there are many methods to remove them, but they quite often create headaches. So I rather don't use them. When I start thinking about how to build script, I try to go from outside to inwards. I don't know, that helps a lot. Okay, so once we have these offsets, we want to kind of remove from, because this is actually outline of the parcel, and this is the outline of the sidewalk. So we want to remove from the parcel our back of house areas, and we want to do the same to the sidewalk outline, which is here. So as you can see now, if you look at our outlines, we don't have sidewalk anymore where the back of house road is, which is exactly what we wanted to achieve. Perfect. Let's maybe also name this. So now when we work around those lines, we will be able to find them easily. So this is our sidewalk outline. It should be curved, sorry. Let's put it pavement since we are in London. And let's call this one parcels. Great. Awesome. Let's turn off the preview here. And let's bring another element to the whole equation, which is residential paths. Okay, so let's copy this surface component. And let's do it exactly the same as we did before, which is bringing it here. Copy this component again, connecting our residential paths to another surface component, and bring it closer to the front of our script. So what we want to do now is actually removing this residential paths from our outlines of the parcels, and then also cutting those so that they can be connected with the sidewalks and merge into one element. So let's do that. Firstly, let's remove those paths from the parcels. And to do it, we're going to use, again, region difference. I'm going to copy this one here. Okay, this is done. All right, works perfectly. And now another step is to do the same with the pavement. Actually, not doing with the pavement. We actually want to trim those lines. And we're going to achieve it by projecting them onto pavement. So we're going to use project component. Perfect. As you can see, I graphed it. And added those curves to curve. I mean, it's the surface, but if you move it to the curve input, it will read it as outline that creates this surface. And I move the pavement towards the B-rep of the projected curve. So what we have now is we need to probably simplify everything because we have the paths of our trees are so deep right now, it's hard to understand what's happening. So let's right click as well on the pavement and click simplify. Let's do the same in here. So what we have in here, we see that we have paths which are with depth of 2. And in here we have paths with depth of 3. Let's simplify as well. 2. Okay, so they should work with each other now. So we need to use now those lines to cut our pavement. Let's use surface splits. Oh, I'm writing something wrong. Surface split. Yes, here we go. Surface split component. And it's connected to surface, the pavement to surface, and the curves we generated to curves. Great. Oops. All right. I just noticed that probably we should connect this to parcels. Because in the end of the day, that's where we want to cut. Okay, let's move it, guys. Let's move it from pavement to parcels. So it's gonna be B-rep here, from parcels, and in here to surface. And let's use shift component to bring it to the same level. Great. Sorry, I probably confused you a little bit. Let me explain. What we want to generate is add those residential paths into our sidewalk. So actually, we need to trim it by parcels, not by sidewalk. That's why I move everything to the other side. So that when let me sketch over this. So the surface literally has this outline rather than this one. Otherwise, they won't perfectly fit. So this is exactly what I just did. Okay, so this looks great. The only thing which is not correct is actually that we divided the surfaces, but we still we actually want to get only those trimmed outlines of the residential paths. So to do it, we need to actually firstly detect which out of all those surfaces that create parcels are inside the outline of the residential paths. I hope it makes sense, but let me do it and maybe you will understand. So how are we going to do this? Firstly, let's create some sort of point inside one of each of the surfaces, and I'm going to use populate for that. Populate as default creates 100 points. We just need 1 point per each of the surfaces. So as you can see, I created 1 point in each of the surfaces. And now I'm actually want to use my surface, my residential path surface, to tell Grasshopper which out of those cut surfaces he should pick up. So let's take this guy and bring it closer right here. And it's used node called point in surfaces. Oh, at the very top. Point in curves, sorry. And just be careful because it needs to be point in curves, not point in curve. So point in curves. And what this component does, it tests whether given point is inside this outline, which is surface at this point, or outside. If it's outside, it gives 0, but if it's inside, it gives us 2. So that's great. So we want to actually use Boolean to turn it into true-false relationship. Let's see if the data tree structure matches what we have right there. It doesn't, what means we need to shift it. So we're going to use shift paths. Shift paths is kind of removing the depth of the path. So in here we have a depth of 3 of each of the branch, and in here we have 2, which is matching our like input. And now we're going to use cool pattern to find this line, but it didn't cut it properly in here. This one is still not cut correctly. Let's have a look what's going on. This one is there. We're happy with that. Okay, so for some reason, this one doesn't cut as it should. Let's use grafting here. Okay, so this is why. Perfect. Let's use grafting here. So let's add grafting parcels. Yeah. So just to be clear, if we go back to the parcels we had at the beginning, we're adding graft over there. And now we are good to go. Perfect. So we're in a fairly good location. What we want to do now is creating the pavement, but like not only the outline that we have in here, but the actual surface. So let's bring this forward. Let's copy this one, bring it forward here. And let's bring parcels as well, actually. But maybe the ones, do we want the ones with the cats? No, we actually want those without the cat, I think. Let me double check. Let's take the ones without a cat. So how are we going to do this? We need to firstly add some sort of fillet in a corner of each of those outlines, because we can't have roads which are having sharp corners. So starting from the pavement, let's add fillet. And then let's add number slider from 0 to, let's say, 10. And I think the fillet in this location would be good, maybe like 7 meters. Great. And for the parcels, we need to use this fillet plus the number of the offset we did somewhere at the very beginning. Let's grab this as a number. Let's turn the wire into fade so it doesn't bother us when we stretch it across the whole script. And let's add those numbers. Oh, actually subtract because it needs to be smaller. Okay, so as you can see, now we have pretty much perfect relationship in terms of the fillets. Only thing which we're missing to actually generate surface of the pavement is region difference, the parcel against the outline of the pavement. So let's take the region difference, bring it to the front. From the parcel, let's remove the from the fillet of the sidewalk. Let's remove the fillet of the parcel, and we ending up with this, which are the outlines of the pavements. Now we can use boundary surface to kind of fill it with a surface because we had only outlines. So yeah, this is looking great. We just need to bring those residential outlines we're struggling with for a moment. So let's bring them down here. Where are they? They are right here. We'll bring it up. So I will use surface to kind of add a little bit of clarity to what I'm doing and bring it right there. And we want to merge them. Great. Now we can flatten everything. And now let's use brep join to join those into one sort of element. But the problem is actually when we zoom in into this location, we still have this faces or edges, which we would like to remove to have a clean geometry. And to do it, we can actually go to surface units and use component called merge faces. With merge faces, we remove this, we have very clean geometry, exactly what we wanted. Perfect. So let's use preview. Whoops. Yeah, this is it. Yes. Custom preview. This is it. To preview this when we turn this button off. And it's use color swatch to give it some color. Let's make it gray like this. Let's make everything preview off. And let's also create the parcel. Let's also preview our parcels. So what I'm doing right now is if I turn off this option of seeing the geometry, and I go to this view, you see I will always see now our pavement with this color. I will make it actually a bit brighter. Great. So let's go back and let's generate also roads and parcels. So we had parcels in here. Let's come back to those parcels. Let's add some. Let's maybe move all this region difference closer to here, where we have already fillets. That will probably make it a little bit more interesting. Yeah. Yeah, this is perfect. Again, let's use boundary surface at the end of that. And let's copy our preview components, which we have here. But for the parcels, maybe we should make some different color. Let's make it yellowish. Okay. Is it visible? Yeah. Maybe a bit too deserty. Okay. So the last thing we're missing are the roads. You remember I told you to leave the outline, the big outline at the very beginning. This is a moment for this outline to come back to our script. So let's use curve component. Let's make the wire faint as well. And let's pull it all the way to the front where our outlines of the pavements are, which are here. So what we will do, we will merge those. This is our, let's maybe type, what is this? This is pavement. So I'm merging pavement, and this is parcels. So I'm merging pavement with this huge outline we had at the beginning, and then I'm going to flatten this. Preview off as usually. And we have all those outlines. All we need to do at the end is copy boundary surface component. And here, as you can see, we have roads generated. Copy the custom preview component, connect it to the surface. And let's make it darker since this is our road. Cool, great. Let's have a look how this works. So let's turn the preview on, or maybe turn off the only highlighted elements preview. I don't know how it's called actually. And let's see how the script works. So we already have roads, we have sidewalks, we have parcels, and now whenever we play with our lines, all those things will adjust accordingly. But this is great. Like whenever you work on master plans, or you can bring it to some smaller scale than master plan, even when you work on 2 or 3 parcels, there is something changing. You need to adjust it quickly. This is how you do it. So what we're missing right now in here are our buildings. So how are we going to approach buildings? Let's sketch over this parcel. But maybe at this point, I will ask if you guys have any questions. Does anyone want some clarification regarding to what we're doing?
Yeah, I think people are just watching along. I think there's no major questions as we go, but it's really cool to see this process. Also for myself, like it's always really good to see how you guys were doing it, because it was kind of like a similar approach, right? That we were always doing, like you draw the lines and
Yeah.
then you script the rest. That always seemed to be what worked really well for master plans.
Yeah. I would say even beyond master plans, even when you work on buildings, I always start from setting out lines. In a building case, let's imagine this is one wall, this is the other wall. I start from these 2 lines, and then whenever we need to do some changes, let's say it's a tower with some podium, which is rectangular, then later down the line, I'm just adjusting those lines and everything is changing in the tower, right? So setting out lines is actually key to any Grasshopper script. Anything we do at KPF in Grasshopper is starting from that.
Yeah, I think this is it's a really good insight for people to understand how these workflows are set up. Let me just check. And then someone's saying it definitely can see how it can be used to help calculate land use and all those kind of things, right? That's just going to be a free byproduct, essentially.
Amazing. I'm very happy to hear that.
Cool. Yeah,
All right.
I'll let you cruise on. Guys, if you have any questions, do put them in the chat. We'll reapproach it again later on. But yeah, this is really cool. Really cool to see.
Awesome. All right, guys. So let's create some buildings. And what we're going to do, as you saw at the beginning, we're going to do buildings in a form of massing. This is what we usually do when we work on master plans. Yeah, so not too often we actually bring facades and more details to it. It happens sometimes. So master plans are actually with facades, which are also quite interesting. But for now, we're gonna do the massings of the buildings. And how we're gonna do this? Let's firstly start from sketching those. So we have an example of a parcel in here. We're gonna grab the outline of the parcel, and then let's offset it inwards. And this way we're gonna have some sort of buildable boundary on which we're gonna draw maybe the towers. And we'll try to position those towers sort of farthest location from each other to reduce the overlooking. And then we're gonna create another offset line that creates the low rise, which will be somewhere there. Okay, so having this in mind, let's continue. So where are we gonna start? We're gonna pull out our parcel, which I had somewhere here. But actually what I want to have is a parcel without the fillet. So let's grab that one. Let's push it a little bit higher, let's say here. Great. So we need to start from kind of organizing the corners so they always start from one end. Why? You will see it later. Or maybe I'll explain you. Let's go back to the sketch. We always want those towers to maybe be positioned exactly in those corners. So that way, when there are blocks facing each other, this tower doesn't have overlooking from, let's imagine some tower here. This tower should be actually here. So overlooking is a problem that we face in every master plan, and we're trying to reduce it as much as possible. And to do so, we actually need to understand how those corners are positioned in the actual Grasshopper script. So we need to sort those corners against something, and this something in our case will be a circle. So let's firstly grab the corners, and I use this continuity to find them. Then I'm going to use area component, because area component has this nice feature of centroid. We can remove area and just keep centroid. It defines the center of the surface. And then in this center of the surface, I will create a circle. I know it's a bit strange I'm creating the circle to do this, but you will know why. I'm gonna give the circle 25 meters of radius. And now I'm gonna actually sort those points around the circle. Why? Because the circle created by Grasshopper on a point is always starting in the same location. So if we add end and beginning of the circle here, and we look at the circle, you see that those circles actually start always from the same sort of direction. So it's a very good trick to organize your points in 3D space of Rhino. Okay, so let's use it to sort those points. We're going to use sort along curve. I wrote it badly, but it found it anyway. So I'm going to connect circle to curve, points to points. And now we should have those points nicely sorted. Let's have a look if they are sorted as we want. So let's use list item to see if we grab the first point, it will always be in the same corner of each parcel. As you can see, every point is, when we grab the first point of the list, it's always from the same corner of the parcel. It's exactly what we wanted. And now we're going to rebuild this parcel again with polyline. Okay, awesome. Let's right click on close and let's press invert. This way we're closing this polyline. Technically what we have right now is perfectly organized outline of our parcel. Now we need to offset it to find the side boundary or buildable boundary of the tower. Let's do that. Offset. Let's create a number slider from 0 to, let's say 15. And let's give tower maybe like offset of 4. Okay, we need to use negative again because it's offsetting outside. Amazing. Okay, so this is the outline of the tower. Let's put a name here. Towers outline. Outlines. Great. Let's copy this and let's do outlines of the low-rise. So low-rise outlines. And let's give it maybe 7. 7 should be okay. 5 and 7. Of course, you can choose different numbers if you need to. And now let's focus on the towers and let's create those towers into different corners of the parcel. How are we going to do that? We will start from, let's start maybe firstly from cleaning our paths, and let's simplify. So now we understand how the paths are built and how deep they are. So we have depth of 2 in here. Let's explode it. Awesome. And then to kind of find the location of this tower, we probably need only this line and that line, because that will be sort of setting out line of the tower. So let's remove every second line using cool pattern. And then let's use a panel where we will actually describe the panel, the pattern for this cool. So panel, I put 1, but I'm going to add also 0 below. And right click multi-line data, so that now Grasshopper will read every single item here as individual, each row as individual item. And this way we managed to get what we wanted, meaning those setting out lines. Now we need to cut those lines so they become one side of the tower outline. To do so, we're going to use evaluate length. And this is a good moment to bring actually the depth of the tower floor plate. So let's start from, I don't know, we can have probably the lowest like 25 up to 40. But we'll set it up maybe as something which works quite well, which probably 31.6. Okay. So we are already getting what we wanted. The only thing is that we need to remove those long lines in each of those setting out curves. To do so, let's use shutter. And connect the parameter output from evaluate to parameter of the shutter. And this way we cut those lines with this point. And now we need to find the shorter line. And to do so, we're going to actually sort it using the length. Then sort. And then let's, in this list which we sorted, let's find the smaller item. Because as you remember what I explained earlier, sorting use keys that define the organization of the values. And in our case, I organize it against length. So if something is short, it's going to be first on the list. If something is long, it's going to be second on the list and farther. Okay, so we managed to get the first side of the tower outline. We need to get another side, and we're going to get it by offsetting. And let's offset it with the same number as this one that we used to define the edge of the outline. Okay, once we have this one in place, let's use ruled surface. Ruled surface use two lines to it connects two lines and creates surface. But you can see that those outlines appeared in wrong locations. So it happened, but because the offset went in wrong direction. So let's use negative in here. Connect our 31.6 number to negative and then to the distance of the offset. Okay, and now the tower is in right location. Cool. So we have tower outlines. Let's look at the low-rise outlines now, which is here. Okay, I would maybe give it a little bit more of that. Maybe let's give it 10. I think it would work a little bit nicer against those towers. How are we gonna get this now? We will grab these outlines that we just created. Actually, we're gonna copy all that thing. And the only thing we will change is the slider. Because we need it a bit more than 15. We will probably, let's put it 25. Put in there 25, but let's increase this number to maybe 20. And you can see that this component turned red. It's fine, don't worry. It happened because some of the outlines, like for example this one, are not deep enough to accommodate offset of 20 on both sides. So the offset didn't happen. But whenever there is enough space, those offset happen. So now we're going to merge this one, which is the external outline of our low rise with the internal outline of our low rise. You can see that our paths are a little bit mixed. So let's simplify it. Let's simplify in here, yeah. Okay, now they're clean and organized. And let's use boundary surfaces to generate outlines of the buildings. Okay, this is great. We have both outlines, but we still have a class between towers and the low rise. So we kind of need to remove actually the outline of the tower from the outline of the low rise. Let's do that. Let's see firstly how our path structure looks. So we have depth of 2 in here. There is lots of things going on in here, so let's simplify. Okay, so we have 3 in here, which is understandable because we have 2 objects per 1 parcel. What we want to do now is actually shift this so they are the same. Great. Great. And project those outlines of the towers on the boundary surfaces, the outlines of the low rise. And this way we created cutting lines, which we're gonna use to to cut the outlines of the low-rise. So let's use surface split. Great. Let's check if the structure looks good in here. It doesn't, meaning we need to shift it. Oh, and I use actually shift, which is not part of the original Rhino components. Let's use the actual original as we promised. And let's copy this one farther. Let's see if this is looking good. This is looking good. Okay, so those surfaces are already cut. The only thing which the only problem that we have right now is that we have both the outlines of the low rise and those remaining pieces that we don't really want. Okay, great. So let's check. Let's remove those which we don't want, and we're gonna actually repeat the operation we did earlier. Actually, I will build it again, so I don't bring too much confusion. Let's use populate again. You remember the count is 100, so let's use 1. So I created a point inside each of those surfaces. Now let's check. Which of those points live inside the outline of the tower and which one don't. So firstly, we need to shift this guy again because the structure of the data is not matching the structure of the path structure doesn't match the path structure of our tower outlines. Are we good here? Are we good in here? Yeah. And we're gonna use points in curve component, curves actually. All right. And we use cool pattern to remove those which we don't want. As you can see, we remove them, but we actually want the flipped side. We remove now the low rise. We want to remove the remains which are inside the tower outlines. Boom. Okay. This is it. So we have the whole base ready. Exactly what we wanted. The next step will be extruding this. And we probably want to extrude it by certain amount of floors, depending on the attractors I mentioned earlier. So we need to create actually as a script that, let's sketch over this. We want to create another portion of the script that measures distances from the center of each of these towers and low rises, measures these distances, and says, okay, the closest are the tallest and the farthest are the shortest. And let's maybe, yeah, let's try this and let's see how it works. Firstly, for clarity, I'll create surface, I'll big surface component, and I'll call it low rise outlines. And for the towers, tower outlines. Let's use faint in here, faint in here. Awesome. Now we need to bring those attractors to Grasshopper so he sees them. We're actually going to go back all the way to the input side. Let's grab this chunk of the input, copy it, and move it to the front. And let's grab this layer, height, and then let's copy this panel. because we want to grab also those sub layers, starting from the low rise, then grabbing high rise as well. Amazing. What I did was right click, multi-line data, meaning Grasshopper reads each row as individual item. And if you zoom in close enough to concatenate, you realize that there are those plus and minuses popping up. Click on plus, that creates another fragment or input, fragment input. And this way we actually created two paths because we have two rows in here, which start with this name and have just different end. If you have a better look at this, they are exactly the same at the beginning and changing only at the end. That is great. So the component, the query model objects is already sees them. And what is also amazing is that it divides them into individual branches. So if we use explode tree right here, we're gonna have model curve, which is visible right there, which is responsible for high rise. Not high rise, for the low rise. And we're gonna have model point, which is responsible for the high rise. So for the exercise of getting the tower height, so we're gonna use the point. Let's grab it. And what we want to do in here is measure the distance from the tower center to this point. And then we'll have to somehow remap those numbers into heights. Okay, so let's do all this. Let's start from area component. Again, to get the centroid of the outline. Let's bring this point closer, use distance component. So this component is measuring distances between all those points. I'll actually use also number here. Why? You'll see later. For now, let's just do it as it is. Then remap numbers. So this component is changing the input value by certain domains. So if you, for example, have, and it kind of replicates the same relationship between the numbers. So if I will maybe show you how it works in practice. That will be easier to describe it. Let's just add the construct domain on Archie domain. And we want to have towers starting from, let's say, 15 floors, going all the way up to 60 floors. Copy it, put it into domains, construct domain, and let's give it 50 here. We need also bounds. So what this is doing is checking what is the largest and the smallest number in those measurements we did in there, and turning it into domain. Okay, let's see what's happening now if we try to extrude all this. Oh, we need to also multiply by the floor height. Sorry, multiply floor height. Let's start from 2.5 and let's go all the way to 4. And maybe for now, let's do 3 meters. Perfect. Let's grab our tower outlines to the front. And now let's extrude them. See what's happening. So I use extrude component and I use Z vector. So we're extruding vertically up. All right. So the numbers haven't changed because what we need to also do in bounds component, we need to flatten it. Okay, now it works. So this is not exactly what we need to achieve, right? We wanted actually the towers to get the tallest around our point and get the smallest everywhere where it's fat, like depending on the location. This tower should be the smallest right now. So let's do that. It's a very simple operation to change it. We just need to change in domain starting from 50 and ending on 15. Great. It's not perfect, but it's already going in the direction we wanted to go. Let's add a little bit more. Let's make it a bit more fun, because in the building that in the real scenario, if you have a, let's say, center of the city, quite often you're gonna have one dominating the neighborhood tower and gradual decrease of the height towards the ends, right? So to do this, we'll have to bring a bit of calculus into our equation. Let's go back to our script. You remember I placed this number component here. Let's expand this whole thing quite significantly, I would say. And now we will actually use, again, remapping. Let's copy it here. The only difference is that we don't need the target anymore, so we can disconnect it. And it will set it up to default, which is from 0 to 1. So what I did, the operation is called normalization, meaning bringing all the values from whatever they were into the values from 0 to 1. And now we want to add a component called graph mapper. It's one of my favorite. Basically, you can use it to create charts. So right click on it, graph types. Let's use this one. It's called Baser. And let's create some sort of like a sinusoidal shape in it. It kind of remapping a little bit the numbers. You're shaping the numbers so they adjust in direction we head in here. Great. So now we can connect this back into our remaining part of the script. That looks good. Great. Awesome. Let's see how it looks. Yeah, this is already looking much better. I would say maybe the towers on the edges are a little bit too tall. Let's give them 12. Let's have a look how this works now. Yeah, that probably looks more like an actual city. What I think is missing is a bit more randomness in their height. Let's add that as well. So let's make it a bit random as well. That's gonna happen in here. Let's use integer to round the numbers that come out of this component. And then let's use random nodes and we need to give it a range of numbers that it creates. So this one, you give it a number, you give it a domain, and it populates the number of random numbers inside that domain. So the domain that we create, let's construct domain. Domain. We wanted to we want some buildings to drop by maybe, let's use number slider for that. From maybe -6 floors. And in some locations, it wouldn't go all the way up to 6 floors. So let's start from -6. And let's connect here and turn it into 6. Let's put it into the range input. Then let's create another number slider from 0 to 100. We use this one to change the seed. Seed is pretty much like this component is creating random numbers, but you can also change the way it creates those random numbers in very simple words. And the last thing is we want to tell him how many those random numbers it needs to create. But the problem is that we have fully defined 3 in here, and we need to somehow firstly destroy it to find the amount of numbers to create and then bring it back to the original structure. So firstly, let's check how many numbers we need using list length. It's connected to list length, and let's flat it. So this way we have 30 numbers that needs to be created. Awesome. And now let's rebuild that tree using unflattened, I think. Yeah. And let's give him the tree it wants to create. Okay, so we brought it back to the same structure. All we need to do is add those numbers. And also let's keep it as integer in here. Add those numbers into each other. Let's see how those numbers look in here. This is 3. Sometimes it's 4. Sometimes will be -4 floors, 5 floors, +6 floors, minus. That's great. Okay, let's connect it to our multiplication. And now, as you can see, the city is becoming more random. If we move the slider, we can look for the random level of randomness or type of randomness that we like the most. Awesome. We probably want to also calculate the areas. As at the moment, I'm creating pure massing, and we want to also have cores. So let's start from the cores. We'll grab cores from here. We'll just pretty much offset the outline inwards. So negative offsets by some number. Let's use number slider again from 4 to 10. Set it up at 9. And now let's use our old friend, which is region difference. From here, removing this one. Awesome. So this is our core boundary surface. So the core is in here, and this is actually our floor plate. So again, let's use boundary surface. And it's connected here. Okay, so this is actually massing without the core. And if we copy this guy there, we're gonna get the core. Let's create the surface for clarity. Surface. Oh, it's actually BREP, sorry. BREP. So this is our tower massing. And this is our tower core. What we're missing in this whole equation is the floor plates, and then obviously the low rise, which will be easy because we just copy everything. Okay, so let's get our floors as well. How are we going to do that? Like this is a good moment to start because this is telling us how many floors we have. So all we're missing is some sort of series component, which will tell that the floor height is 3, which we had over there. And it will tell to create the floor to floor height or distance from the ground of each floor And this is also how you would do it when you work on building, normal building, not only master plans. And what we will do now is copy the Z vector, use move component, connect Z vector to motion to define the direction and also the power of the vector. And let's bring our flow outlines. Let's check only if our data trees match. I'll simplify here. Yes, the data trees match. Great. So we have now also flow outlines. Actually, we want this ones here, right? Because we don't want car. Yeah. Cool. Let's extrude it by the floor height. And we need 0 vector by the floor height, which is 3 meters. All right. Let's add previews to this. So this is tower massing, tower. Let's call this tower floors. And all this data requires some preview, which we can take from here. The tower core, we quite often use gray color. For residential buildings, we use sort of yellow. That's like a standard KPF, and I think that's a general standard. That'd be like this. And we're going to use the same color for tile floors, so we just flip between 2 of them if you want to. So we're going to keep maybe the massing off and just keep the tower floors. Let's remember to turn off all the remaining elements, the preview of the preview of those elements, and let's see how it looks in 3D. Okay, we're getting there slowly. We just need areas, and then we're gonna copy all this to our low-rise, and we'll be almost there. So let's calculate the areas of the towers first. So what we need is the floors. Let's grab a surface, call it floors. Let's bring it here. So let's simplify to understand the structure of the data. So as you can see, let's maybe preview it using Param Viewer. This is our tree. Each tree indicates a different tower, and these are floors. So we need to measure the area of each floor first. And then we're gonna actually combine all these areas into one number. And we're gonna use mass addition for that. So as you can see, all those areas here are dropped into one number. And because it's a master plan, let's use integer to round those numbers into integer numbers rather than floats. And now we want also something that will display this these numbers on the screen when we actually spinning the model around. So let's use tag component. And let's use the centroids that we already have from the area component. The only thing is we have too many of them, right? We want actually some average points somewhere in the middle of the tower. So let's use average component. Or average node, and then put it into location and to text. So this is it. Let's use color swatch. And for the towers, let's keep it white. It looks good. Let's preview what is happening in the model. Great. So now the towers are visible. The floors of the towers are visible. Cores are there. And now if we move our attractor to change the location of the tallest objects maybe to the side of the plots or our model. Let's do it. But what I want you to see is that this is the tallest tower and it has the biggest amount of area, which is what we should expect. The shortest tower has the smallest amount of area. Let's move it there. Okay, so the towers follow. We also have this nice smooth transition. The heights are also changing depending. They're quite a little bit random as we wanted. Let's do the same thing with the low rise. So to do it, we will firstly, let's expand this so we see better what's going on. You remember we were having the outlines ready? Somewhere here. This is where we need to go back to. So we will grab, let's log first in the canvas. Let's grab everything that we created, including this actually. Let's copy paste it. And let's drop it all the way up. I'm going to use almost the same script for that. The only difference is that we're going to switch low-rise outlines with tower outlines. And there is a very convenient trick to do it. If you press Ctrl and Shift, then you can replug those wires easily. Okay. Before I actually free the canvas, I will actually lock what's happening at the front. I'll turn it off just in case something doesn't work. We don't want our Rhino, Grasshopper file to crash. Firstly, we need to understand if this calculations work well, and then we'll gently turn each of those components on. That's what I usually do when I copy paste things. But the other thing is that we don't want to use this point as an attractor of the height. We want to use the curve now. So let's bring the curve. Let's make this smaller. I will also turn off this part of the script. So we work only on that one. This is off, awesome. Okay, let's unlock it. Let's bring our line. This line is visible right there. And now we need to measure the distances slightly differently. We can't use this distance between two different points. We need to measure distance from the centroids to this line. We're going to use pool component, pool point actually. Let's put curve into geometry, the centroids of our low rise into points. And this way, what Grasshopper did was finding the shortest path between the attractor line from the centroid of that floor plate. If we draw a line now for a test, actually, you see this is what happened. That's great because this will let us calculate what's that distance and apply the same rule as we had before. So right shift click, replug it. We can remove that. We don't need it anymore. Let's organize everything so it's nice and neat. Great. All right, let's start launching the remaining part of the script and see how it works. So right click, or you can use shortcut Control E. I'm going to use Control E so it's faster. You can also use shortcut Control Q to make elements visible. Let's say this one. You see, I'm switching between those. I almost never use actually right clicks anymore. I'm trying to use shortcuts all the time. That makes things much faster. Turning on, off, visible, not visible. And also right click F, meaning, for example, flattening, right click G, grafting, etc., etc. So yeah, that's really helpful. Okay, so this looks good. The only thing is that we don't want in the low rise to have so many floors anymore. So let's change those numbers. Let's make the smallest one 5. Okay, 6 maybe. And the tallest one will be, let's make it 5, but I'm gonna actually do, let's say 11 floors. And also this random step shouldn't be this big because that's more than the actual whole building. So let's make it maybe -1 and 1. The seats, whatever, just change to something else. Great. Let's see if everything in here makes sense. We don't want cores for the low rise because there won't be specific core in the center. In the low rise, you're gonna have probably 2 smaller cores on the side. So we actually will remove that part of the script. Right here, connect this one there because we don't need to cut anything anymore. And let's start turning things on. So this is our massing. It really reacts to that curve. Let's test it as well. Yeah, it reacts. Now the buildings in the center are the tallest. Let's turn off also our floor calculations. So here I think we have some small error. Let's have a look what's happening. Do we? That's a question. Or maybe just one floor. Yes. But everything else looks good. So let's have a look what's happening with this one. Let's start from here. When I have some error, I usually try to simplify our data trees as much as possible because usually those mistakes come from the depth of the tree. So here I have depth of 2. In here, we are still in the same depth. Depth of 2, depth of 2. This one looks good. And here you see the depth increased to 3. And this is where the mistake is coming from. So we need to shift it. Still doesn't get it. Maybe we should go all the way around. Let's try that one. Okay, now it seems to be working. Okay. All right, so that was the issue. Make it massing. Okay, we are all good to go. The only thing which, no, everything works. The area is calculated. You just want to change this into maybe black. Great. Oh, and let's maybe make low rise orange. Maybe let's keep orange 3 yellow as it was, but let's make towers a little bit orange. Great. Let's have a look how this works now. So attractors are right now in this location. Let's pull the low-rise attractor to this location. So we have the tallest building, low-rise buildings there. Great. Let's find also our high-rise attractor. I can find it probably this way faster. Oh, it's there, hidden. Let's move it over there. Great. I see there is also a clash happening between the residential paths and the low-rise that we can quickly fix. Let's see why this is happening. In the meantime, drop your comments because we are almost at the end of this tutorial. and I will try to answer in this last 10 minutes. Okay, so this is the reason why this is happening. We never remove those from our parcels. Let's do it now, hoping that it will work. Okay, it's done. And it works as well. So let's play a little bit of those over here. Awesome, this works nicely. Great, so this is the full script. As I mentioned, it's a very useful tool when you work on master plans. It's great also because you can scale it. And we're using pretty much the same thing quite often in the office. We adding some more complexity to it, like for example, making the outlines of the towers irregular so they fit the outline of the side boundaries. We quite often add facades to all those buildings using Grasshopper fully. So technically we generate all this only in Grasshopper. And what is also quite important, once we have all those things set up and we're happy with how they look, we quite often bring them to Revit, where we do all sorts of area calculations, which are more detailed than the one I'm showing you right now. Or simple sections, simple plans for master plan studies. So yeah, I guess this is it from my end. Thank you so much.
Awesome stuff. Yeah, I'm really glad you showed this process because it's so like it's such a great example of how people do this stuff in practice.
Thank you. It's a pleasure to show a little bit of our approach and share it with everyone else.
You made it seem very smooth, but I'm sure people will go back and rewatch this, and I think they can download the full script, right? I always find if you're kind of working these things out, you can go back and forth between those two. But yeah, I'm got a curious question. Do you find what's the input for that? Do the teams like hand draw the master plan and then you kind of like draw over the curves and recreate it in Rhino? Do you find the hand drawing still takes like a strong point in the design process?
I think in the whole design process, it's always back and forth. We sometimes starting from some sketch, starting with doing some brainstorming in Rhino / Grasshopper. Sometimes someone creates something very interesting in, for example, Grasshopper and Rhino, and then we bring it back and sketch over it again. And so this process, it's a very fluid process, and there are many steps where we're actually going back and forth. There's always sketching happening, regardless of how complicated and amazing technology you're actually going to use. There's always a lot of sketching happening because that's obviously the easiest way to share your visions, share your needs or wants, especially when you talk to the client, especially when you talk with some principals, for example, in our case. So yeah, this is happening quite a lot in both sides.
Yeah, I always fell into the trap of trying to script the entire master plan. I always find sketching is really good for the kind of big vision because sometimes it's slightly illogical, right? You have like a massive, park coming through it that kind of makes no sense, but you got to just draw it, and you draw those highline things, but then you can plug it into Rhino. You just essentially just have to draw the center line curve things, and boom, your script just takes you on from there. So yeah, I think it's really great you showed this workflow. I think it's incredibly powerful.
Thank you so much.
Let me bring the Finch guys back in, just in case they want to add to this before we take a little 10-minute break and tag over things to the Finch guys. But yes, I was curious to see your thoughts on this because I remember back in the day of when you were experimenting with Finch, it was like about floor plans, but then you were also experimenting kind of on a master plan level, right? I remember you drawing like this really cool script of roads and then all this kind of stuff, and now you're kind of focusing. But talk to us about how how you're zooming in and out, and will you get back to that scale?
The scale of plans from plans to floor plans, or what do you mean?
Yeah, yeah, like could you see Finch evolving to helping to generate the massing of like entire master plans as well?
Yeah, maybe in the future. I mean, things are going really fast now, but I think just as you mentioned, Ollie, in the beginning, we worked with terrain, we worked with master plans,
Right.
but we in dialogue with customers, we felt that the biggest pain they had was the interior or the inside of the building, and and we also saw a lot of other companies working with master plans and I mean. Forma, Oracle, all kinds of folks are doing great jobs there. So we decided to focus and be very focused on the inside. And I probably in the future, either we expand or we plug into to some of the other tools and so on.
Yeah.
That's how I see it.
You focus in and then maybe branch back for the
Yeah,
facade to the building and but,
yeah, for sure.
well, cool. So, guys, let's take a 10-minute break for everyone that's online. It's pretty much on the hour, so maybe we'll come back in just over, yeah, 10 minutes. And we're going to hand over to the Finch guys to take their part of things. Yes, but everyone needs to have access to Finch, and then you also sent me some files I'll share as well, right?
Yeah, so I'm going to continue working on the great script Michelle created here to send things from Grasshopper into Finch. And then we're going to go through how to work with it in Finch, and then we're going to send it out. Ruben's going to show how we get it out to Revit. Uh, some parts going to be a little bit follow along like Michelle do here, and some parts is just me, designing, showing the capabilities and so on. And I will try to be clear about in Finch we have different tiers. I will try to be clear about this is part of the free tier, this is part of the basic tier, and this is the enterprise tier, and so on. So if you're confused that you're missing any buttons and so on, I'll try to explain it.
Awesome. Okay, guys, let's have a little 10-minute break. Let's come back at 10 minutes past wherever you are in the world. Here in the UK, that'll be 10 past 5, and we'll pick it back up. Go and grab a beer, a coffee, or wherever you are in the world, whatever time zone, the appropriate drink, and we'll see you in about 12 minutes.
Lovely. See you.
All right, guys, we'll start to pick things back up. For part 2 of this workshop, we'll get Finch up in the mix. We'll let everyone come back online for a sec. Let me bring the guys back on stage. One moment. What's up, guys?
Hey.
Hello.
So I think, Mikhail, you're pretty much can crack open a beer. It's the perfect time to hit the pub in the UK and sit back. But yeah, it was amazing workflow, and it's just like gold content for people out there to tune in. Yes, but I think we'll hand it over to you guys to take it away with Finch.
Thank you, and thank you a lot, Michelle. I think before we get started with our part, I think this is one of the best parts of running a startup like Finch, the ability to collaborate with all these amazingly talented people like Michelle here at KPF. I mean, we talk to people from SOM, Herzog, and so on. It's just super fun for us as well to collaborate with you guys.
It's a lot of fun as well from this end.
Yeah. Let's see if I can mess up your script now. So I figured before we jump into Grasshopper and Finch, I'll going to share a couple of slides, just a quick ones, who Finch are and so on. So I'm going to go ahead and share my screen.
That's great. I'll put us backstage and let you guys take it from here.
Okay. So Finch, where AI and architects design together. So it's me and Ruben that's going to take you through this workshop. I'm going to start with the Grasshopper parts and the Finch parts, and then Ruben, our Revit expert, will show you all about how to get all of the great architecture that we created into Revit. And a little very quick backstory about Finch, why it started and how it started, is that me and Pamela, our CEO at Finch, used to run an architecture studio in Sweden. We made a lot of in-house tools similar to the one Michelle showed here. And I posted it online just to share it with colleagues and so on. And when I posted this video, the adaptive plan, it really took off, and firms all around the world started to contact us and see, can we buy this solution and so on. And that's when we folded the architecture company and started Finch, that now has grown into to mature software company with clients. Here are some of them all around the world, and we have a great waiting list of architects eager to get up and running. And we're doing our best to get as many as possible in as soon as possible. A little bit, or a couple of words about the workflow in Finch. So the massing is at the moment done outside Finch. We focus on the inside. So that first part here, uploading building exterior, that is what has been shown here by KPF. And of course, we used Grasshopper to do that. I'm going to do that as well. But you can also start in Forma, in Revit, or in Rhino if you prefer that. Then we're going to go into Finch. This is my part where we generate circulation, floor plans, and so on. And then here at the end, export BIM and CAD. That's where Ruben come in and showing how we get into Revit. So we're going to go from Grasshopper into Finch and then into Revit. Okay, that's it for the slide. So let's jump into and start a project in Finch. As I mentioned, it might be, I mean, you can follow along. It might go a little bit fast and so on, but the recording will be up on YouTube, so you can go back and have a look later. And the first thing I'm going to do here in Finch. Now I'm signed into Finch. I'm going to create a project and I'm going to call it ATN Live. There we go. So now I have my project in Finch. Of course, it's empty. We haven't created anything yet. That's what we're going to upload now. By clicking on the name here in the corner, I get back to the project overview. This is how it looks. So now we're going to create variants and bundles, because now when we're working with this magnitude of or the project at this scale, I prefer to break the project down to multiple files and link them into a master file to keep the performance up in the files, and also the ability to collaborate and so on. But I'm going to show you what I'm talking about. Okay, so let's bring Rhino in here and let's start Grasshopper. Here we go. I'm going to open the file. So this is the file created in the previous part of the tutorial. I've added some things here in purple. This is to send things into Finch, and I'm going to go through what I've done and so on. So it's going to be a little bit techy here in the beginning, and then we head into Finch. I'm also logged into the Finch extension in Rhino that's been downloaded through the package manager, and in Grasshopper, of course, I now have the Finch tab with all of these kind of things. So the first thing I would like to do just to get started is to send the context or the roads and the pavements and so on into Finch. And here in the script, I have it down here. That's the output of the script earlier produced. And I've connected it to a custom geometry upload component in Finch. But this is where we're going to start. So if I open the browser, here we go. I'm going to name my first variant here context. I think that's an appropriate name. I'm going to open it and then I go back to Rhino. It's going to be a little bit back and forth here in the beginning. And then I have my Finch component here. It asks for some input. It's project name, ATN Live. I actually have it over here. You can see that with the hidden lines as you can do in Grasshopper. Context is the name on variant, and now by clicking the button, I load it in here. And if I click send on this context geometry node, there we go. You get some information. Now we have uploaded it. It just very fast, so it just went down to finished already. And if we head into the web app, zoom out a little bit, you can see that here we have our context. So just a click of a button, we have the context up in the web app. And if you update your Grasshopper script, a single click updates the geometry in the web app as well. Okay, so next step, we would like to send all of the buildings that we would like to work with. But since we're going down to a high level of detail, all the way down to furniture, I think it makes sense to split it up. You might be familiar with the workflow both in Rhino and Revit, where you have different buildings in different file, and then you link them into a master file. And that's the same thing we're going to do here. But in Finch, we call it bundles. So I'm going to go out here again, and I'm going to create a bundle. That's a bundle of variants. I'm going to call it master plan. There we go. Okay, so now we're setting up the project, and that is also an important part of working with these massive master plan projects. Let's head back to Rhino here. So I'm just going to select everything and turn the preview off. I usually like to do that to navigate. It's also a great way of learning or getting to know the script, turning everything off and then turning different nodes on and off to just see what they're doing here. So if I use the outlines of the different plots here, I think that's a great breakdown to create variants, to divide it in like this. And then I made a little part here. It's very simple. It basically takes the plots created in previous part here. It measures the length of the list, creates a series, and then we have a component that's called create variants in Finch. Let's see. So everything is up to date. There we go. Create variants in Finch. And since we have a lot of them, if I click this one, there we go. I get a little warning. Are you sure you want to create 17 variants? I'm very sure, yes. And if I open the web app, you will see that it actually starts to create empty variants here. And this is really neat if you're working with really big things, so you don't have to do all of this kind of things manually. And if we go into our bundles now, oh, sorry, I clicked the variant. I can also choose which one I would like to show here. So I'm just going to click all of the variants here. There we go. Let's see, there we have the context. Very nice. Back to Rhino. So now I've prepared everything for this great project. And the next thing I'm going to do is to send the buildings created. So I have the script here. I have all of the buildings created, the cores and the low rise and so on. Finch asks for a building mass for a single watertight mass. So we don't want to send all of the stories. We can match that later, but we want to send each building as one mass. So what I've basically done here is that I've taken the buildings that we created and used the solid union and the face merge component to basically create this kind of things in Rhino. As mentioned, Ollie will share this script as well, so you can go in and see and have a look what we've been doing. Okay, so to send buildings into Finch from Grasshopper, you use the building mass upload. It asks for the buildings. It asks for what variants to send. The same thing I've done here. I've created a link here. I have the project name, and I would like to send it to all of the variants named mass something. That's what I created. And if I click here, actually I'm going to move Rhino over here. Let's see, we can do it like this instead. Okay, so now I have the web app here. And here we have the script in Rhino. Let's see, I've loaded everything. So if I send my buildings now, let's see if I get that. It's uploads the building, it's queue someone, then it's processed, and as you can see, it's starting to pop in here to the web app. And now all of these buildings are put in separate files, so you could be multiple architects working on a building each and so on. And as you can see, all of the square meters are popping in here nicely at the side as well. The next thing I would like to do is to upload center lines. I'm not going to go too deep into it. What I've done is basically taken the center line of all the buildings, just an offset of the script previously. So I'm just going to send that as well to prepare our file. And if I go into a building now, let's select this one, just double click it. It opens in a new tab. You can see it like this. And if I go into a story, there you go. I can see that I have my center line sent into Finch as well. It's a really neat way of sending things back and forth like this. And I personally really enjoy the power of Grasshopper, creating a lot of things, and then the simplicity of sending it into Finch and get all of my key figures in place and so on. Okay, I need to refresh my data. What that means is that I refresh this Finch component to have all of the latest data that I've just sent, so everything is up to date. The next step I'm going to do is to send the story walls up. And what is story walls? In this case, it's the core Mikael created here earlier on, and I would like to send that not as a volume, but actual walls into Finch. And what I've done, if I bring Rhino back here, what I've done here is that I've taken the towers or the tower core that we created earlier on, and I've taken the stories from Finch. This is now the things that we've uploaded, and I just project the core onto all of these stories to get walls. So this, now we have walls within the towers. And this operation, since this is such a massive project, if I were to send it, I think it would take 3 to 4 minutes for it to process all of that. So I prepared a file for you to follow along here. So if we go into the web app again, this is where we left. We've uploaded all of the buildings and so on. I'm just going to jump into a prepared project that has the exact geometry as the ones we've sent, but I've also sent walls. You can see that they are up here. I mean, in a small project, it goes in seconds, but it is a really massive project with 17 buildings. Okay, so the last part I'm going to do here in Grasshopper before we jump into Finch and generate to just prepare my file is to, let's see, where did it go? There you go. Here I have my master plan. Of course, I need to send it to the correct place. And since I prepared the file already, I now need to change the project name to ATN 03 walls. So this is how you connect it. I mean, whatever you name it in Finch, you just simply add it here in Grasshopper by name, and the data is downloaded. There you go. The last thing I would like to do here in Grasshopper is to send programs. I could, of course, set this in Finch easily, but since we already have created it in Grasshopper, I think it creates a nice flow if we send them from Grasshopper into Finch. And what I've done is that I've taken all of the cores, singled out here in this script. It's and then I've have all the circulation units down here, and when I click now send, I will send all of my residential units and all of my circulation units into Finch. So here we have the web app. Here's Grasshopper. Let's see. Let's give it a shot. As you can see, it starts to upload. It's queued, processing, and as you can see here to the left, it starts to pop in to our model in Finch. As you see, there's a lot of things. It's a massive project. It's a lot of things uploading here. But there you go. Now we're done. Everything from the great script has been uploaded to Finch. And we're ready to dig deeper into the buildings. So let's close Grasshopper and Rhino for now and focus on Finch. And all of the things I've shown now is part of Finch free. So if you sign up to Finch, you can start sending your geometry from Grasshopper into Finch. And all of the editing tools and so on are part of Finch free as well. Okay, here's our massive project. As you can see, we have a gross floor area of 1.3 million square meters, where almost 1.2 is residential, and then we have circulation up here. But I'm going to dig deeper into one of these buildings in this workshop. Of course, we could have my colleagues working on the other ones and so on, but let's focus on one here in this tutorial. I'm going to choose this one. Double click to open it. There you go. Here we have the building. And now when we're in variant mode, we have a lot of different tools that we're going to go through. For example, you can single out to see where the circulation is or the residential part and so on. And as we start adding data, you will be able to see a lot of different things. So you get all of the space type is, and the residential unit mix and so on. But I'll get to that. Okay, let's start generating things. So I'm going to head into a story here. This is how it looks. I would like to add, before I start generating things, I would like to add some walls, some dividers, because I already now know, since we have these towers going through the building, I would like to keep them isolated. I mean, it's part of the podium, but I would like the walls to go straight down. So I'm going to use our editing tools for that. And what I'm going to do is to simply select the wall tool. Let's make the walls, let's make them 350. There you go. And I'm going to draw walls here, here, and the same for the tower down here. And now I snapped it to the corners. That is typically not how I would like my walls to be anchored here. So the easiest way to fix this is to use the align tool. I usually just click A, but I guess it's up here. Align. I select the wall I would like to align to and what wall I would like to align. And then I work my way around. And this is a big part of Finch, because everything that's being generated or uploaded can also be edited. So you as a designer have total freedom of the design and what you want to create. Okay, there you go. I'm very happy with that. So far, everything has been part of Finch free. The next thing we're going to look at is part of Finch basic. And this is the unit mix we're going to generate. And I've got a unit mix here. I can show you the piece of paper. I got it from Pamela in the office. I told her, just give me a unit mix. You play the client here, and I would like to fill the buildings with this unit mix. So I'm going to select these parts, the low-rise part of the building now. I'm going to click generate, and I'm going to generate unit mix and corridors. And I'm going to start with the corridors. And in Finch, we can generate unit mix and corridors. I'm going to set the stairwell attractor on the inside to get all of my stairwells on the inside here. And then I have a bunch of inputs. For example, what's the maximum distance if I have access to 2 cores or stairwells? What's the maximum distance if I have access to 1? And so on. And I have a bunch of sliders to play around with. For example, if I want to snap the stairwells to the corners, I pull this one up and it ends up here and so on. I'm not going to spend too much time on this one, but I can show you, for example, if I force the algorithm to go for 1 stairwell instead, based on the exit route distance or the egress distance I've added here, you can see that it's just too far away. So I would probably go for another solution. But in this particular, we're going to freestyle a little bit. So we know that we will need more than 1, but I would like to connect it to the towers as well. So for now, let's just keep it like this. and say apply plan. There you go. Okay. The next part is to start with the unit mix. Before I do this, I've designed a lot of residential towers and have a lot of cores and so on in my library. And I'm going to show you a little bit about the library here further on, but let's start generating some things. I'm just going to make this a little bit bigger already now to accommodate for some stairs and so on. I could of course have added this one earlier on. Let's see, let's make it, let's make this 7 meters by a little bit bigger in this direction, something like that. I'm sure actually maybe it would be nice to pull it in a little bit. Let's pull it in a meter. And maybe I can align it with this actually. Make this 7. Yeah, something like that. And then I'm just going to click generate floor plan. This is actually part of the enterprise package, generating floor plan. I will get back to you regarding that. I'm just going to set it up a little bit here. What this does now is that it checks my library if I have some suitable cores here for my project. So give it a little bit of time when it analyzes. Yes, I have one here that I think could work nicely. Let's just put it on the assign it, and I need to flip this one. I think this is a suitable one. 3 elevators. Yeah, let's go for that one. And I'm actually going to copy this one and add it down here as well. Do you remember how big I made it? It was 700 by something like that. Just going to copy it, paste it, and now they are linked. So when I copy paste in Finch like this, they are linked. That's really nice. So if I update one of them, the other one updates as well. Okay, very nice. So I added my cores here, and now I'm going to start generating my unit mix. The little note I got here on the unit mix, it says 46, 70, and 93 square meter units for this project, and then they want some bigger ones as well, 116, 140, and some really big ones in the tower. So my idea is to put the big ones in the towers and the smaller ones here in the lower parts. That is, of course, a design decision. Another designer might have said something different, but this is what I'll try to achieve here. So I'm going to select the areas. I'm going to click generate, and this is part of Finch Basic. Anyone can sign up to Finch Basic, €49 a month, so and run these kind of things. And I'm going to select unit mix around existing corridor. And when it starts to analyze where the corridor is, and then it tries to find the optimal mix here. I'm going to add the mix I got, so it's 46, it's 70, and it's 93, and we can just keep it, an equal mix of these things. And then it asks for some input parameters here. I mean, it's basically the size and unit mix I'm interested in. I'm going to keep the shape aware, and what the shape aware means is that it tries to snap to this kind of corners and so on. I mean, if it just went for areas purely, you might find the ultimate solution like 10 centimeters away from the corner, but I think it just creates more nice architecture when we kind of try to fix these kind of things as neatly as possible. But it is also always a compromise, of course, because the unit mix and the building might not be 100% suitable in size. And what that means is that we place all of the units here. You can see that it matches the sizes very well, but you will always get 1 or 2 units that kind of takes up the discrepancy here in the sizes. But I think it starts to look really good already now, actually. So I'm going to pause it, and I'm going to add it. There you go. And as you can see, I have very precise numbers, and I can also open a panel here at the side to see where do we have the unique units. And what that basically does is that it finds all of the units with the same shape, for example this, 70 square meters, and just visually shows it to me. And that is a really neat way of just keeping track of your units, because no developer would appreciate if you came with 6,000 unique units in the project. You want to kind of rationalize it a little bit. Okay. So now I have my units in place. I'm happy with this one. I can of course go in and also manually edit things. For example, one thing I would like to do, I asked for 46, 93, and 70. So it follows very well. As you can see, there are some units that takes up the discrepancy as I talked about. In this case, for example, I might prefer to have it the unique one down here, since it's already an angled apartment due to the design. So what I can do then, for example, is to, let's see, I'm going to change the size of this one. Just make it 1106 to match the other 93, and then I take up the discrepancy over here. I can see that this is, maybe if I make this one, align it with this wall instead, there you go, then this became identical with these ones. And this is kind of, there's no right and wrong here. It's you as a designer that says, okay, this is what I prefer, basically. I'm going to move them over here as well. I think I'm going to do like this. 82, 84, there you go. Let's make this one the same as this one. And I'm not going to spend too much time. I just really enjoy the fact that I'm kind of designing and getting informed at the same time. These kind of schedules are created in real time as I explore and work with my design. And I, as an architect, as a designer, I think this is key, actually. Knowing what you're designing and just getting information in real time as you're designing like this. Okay. I should probably take a break in the designing now and move on. So now I have my units in place here. I would like to look at the towers as well a little bit. To do that, I use the arrow keys, but I can also pull the story slider here, or I can simply double click outside, go out, and I can see I've created the units, and I can double click into a unit or a story that I would like to work with. To create a unit mix here in the tower, I could of course just fire it up like this and let it run and try to find the optimal solution, but it doesn't make sense before I know anything about the core and where to be able to exit it or enter the core. So what I'm going to do first is to generate a core here. I'm simply clicking the circulation. Finch does not generate cores by default, but since I've designed a lot of residential projects, just like, or not just like KPF, but as architecture firms have, I saved the course down to my plan library. So I'm going to use that one. There you go, and just add it like this. And just as I said before, I'm actually going to copy this one down here to the other stories as well. There you go. Let's rotate this one. And here I have some cores. And the reason to why this is important, of course, is so I know when I start to generate the unit mix in the tower that we can access the units from the corridor parts here, so we don't go from the emergency stairwell out to the units. Okie dokie. Let's see. Yes, I promised some larger units in the tower. So let's generate unit mix around existing corridor. And this could, of course, be a repurposing project and so on, where you have a structure in place already that you just want to generate units in between. So I'm going to open this one. And then let's see what I have in my list here. 116. And we have 143. 140, maybe I said. Let's remove this one. And then I think I'm going to go for some bigger ones. Oh, higher up. Let's give it a second. And then I think I need to change some constraints here. Say that dual aspect is allowed up to, there you go. And then we're going to shape aware unit mix. As you can see, there is some playing around with the parameters here. For example, I had my dual aspect size set to 100 square meters, so no apartment larger than 100 square meters was allowed to only have access to one facade. I changed that to 200 here, so now I got this unit mix. That's actually seems to work very well with the things I asked for. Of course, I asked for 140, 116. It's not perfect because my tower has a different shape, and I prioritize to have these neat, kind of extensions of these walls. But I think I can live with the extra square meters here. Me as an architect, I prioritize that. If I pull the shape aware down a little bit, you can see that it starts to fit exactly more exact size, and if you let it work for a while it will probably find it. But I prioritize to have the neat lines like this. Okay, so let's add this one. There you go. So here's the tower in place, and to make it look nice here with all of the different shapes and guide me in my design, I'm going to set up the residential unit mix. Let's give it a second here. This is how it looks. At the moment, I have my unique units. They are automatically created, this diagram, but I would also like to create my own diagram here with residential unit mix. And the way it works is that it has all of the units sorted very nicely here in the project, and then I can see the percentage and so on. But I would like to group some of them. So instead of have 46, 50, 56, 63, I'm going to click this one, add a field, and say all of the units that is between 40 and 55 as an example. It's going to be in this group. And then I think all of the units between 65 and 75, that's fine. Add one more, 90 to 100. And actually, let's add for the big ones in the tower as well. 120, yeah, that's fine. I get some suggestions here. They're usually pretty good. 140 to 150. And let's have one for the really big ones, 150 plus 200. There you go. So now I created a diagram like this. And one thing I like about this one is that you can immediately see that if you have units that doesn't match the desired unit mix here, for example, the unique ones in the corner, then they get no color. And either me as an architect say, I think that's okay for my project, or I can go in and play around with the sizes here for them. Okay, but let's get back to the tower here. I had the big ones here, looks nice, 116. I'm going to actually do like this. I'm going to copy my walls to make sure I have nice vertical alignment. There you go. You can see that it's, if I toggle it back and forth between these stories, it goes very nicely like this. But of course, any architect knows that if you're working like this with a tower going into a podium, you will have some problems here where it lands. Some of the apartment will work, some will not. For example, this guy will have some daylight problems. So that's fine. We can probably put some storage or some technical space and so on. This is just the nature of these deep buildings landing like this. What I'm going to do here in this one is that I'm going to extend my corridor like this. I'll make this the same size. And do the same thing over here to go in there. Whoops. Let's fix that. Got a little, oh, let's see. Got a little thing created here. Let's clean that up. Sometimes when we move, we get that. Let's keep that. Looks very nice. Let's do the same thing for this tower here later. For now on, I'm just going to remove this one as residential. Unset. There you go. This is how it looks. I think we can live with this little thing over here. Looks great. So let's do the same thing for this tower. I would actually like to, yep, I'm just going to do, I would like to use the exact same logic. I'm just going to copy these walls just to get some nice repetition. I just select them and copy them to the other tower. There you go. And as you can see, we have a little bit different tower here. Let's copy the walls up to the, whoops, I was a little bit too fast here. It's going to select all my walls. I think my computer is struggling a bit here. There we go. Nice. Now I know I have the same things in both towers here. And if I go out in 3D, I can see, let's see, it looks great. I have them like that. Maybe I would like to have the big ones going outside instead. Let's go and change that. And the best way to change it, I mean, this is, let's just mirror it. Let's see. Where's the midpoint? Do I have it in the tower? Let's see. What was the measurement of this one? 13. There you go. I think that works better with the big ones out here. And as you can see, although I've generated a lot of things here, I still like to, go in and design it, and have the things I would like to achieve with this design and so on. I think this is a great base to start with. Let's fix these ones as well before we move on. I'm going to draw some new walls. They're going to be 200 millimeters. Let's put it like this, just to connect my design here. Let's go in here, have a look. I'm going to add a door here. The exit route, I'm going to do the same thing over here. Let's have a look at this one as well. There we go. Now I think everything is connected here nicely. And if I turn on my graph, you can see, yep, everything is connected. I also get a little warning. Let's see, what is that? That is just that it's a modeling aid. Here under the graph tab, I get all kinds of aid. I will go into how to work with it a little bit more, but now it warned me a little bit. I had some problems in my model. For example, I mean, if you have drawn a wall and it's slightly crooked and so on, it just helps you, keep track of your model in general. I got to fix it up here as well. There we go. Very nice. Everything is connected, and if I would like to measure the distance, I can use the smart measuring tool, for example, here in Finch. Measure path. I would like an offset of 300 millimeters. I think that's reasonable. Then I can measure the distance from, example, this stairwell. I can measure around corners down to the next stairwell, how long, how far it is, and so on. This is just a great way of doing this kind of complex measurements in the project. Okay, I'm pretty happy with this actually. Let's fix it over here as well. As you can see, my tower, this works great here, but when it lands in the bottom here, it does not work as well. So I'm going to take one of these sized apartment, 93, it's 1106. Make this the same one, 1106, and then pull this one up here, something like that. There we go. This one and this one, let's remove them for now due to daylight problems probably. Maybe we can add a small one down here later on. Let's do that. Something like let's wait a little bit. There we go. I'm pretty happy with this design so far. And if we have a look at the residential unit mix, this is how it looks. I have 15% of these ones, 13 of these ones, and then of course a little bit fewer of the big ones, but I'm thinking that we will add them in the tower here. And if I would like it in the full project, I simply copy, select all of the other stories, paste, give Finch a couple of seconds to calculate and add it to the other stories, and there you go. Then we have it down here. I'm going to wait a little bit with doing that because I would like to add more data before I copy it out to the rest of the project. Okay, so most of the things that we've done here, I mean, I've done a lot of manual editing here as well. That's part of Finch Free. The generation of the unit mix, that's part of Finch Basic, and then the generation of the interior layouts, that's the enterprise package at the moment. So let's start generating some apartments in here. And before we dig into the generation of apartments, I would like to show you the floor plan library in Finch. And the floor plan library, that is the foundation to generate apartments in Finch. Here you gather data and apartments from earlier project, and then when you start generating things, this is where Finch takes the knowledge from. So I'm simply go up to the logo here, and I can click plans. I hold down Control to open it in a new tab. Let's do it like this. This is how it looks. This is my floor plan library. This is floor plans from previous projects that I've designed in Finch or elsewhere. I have my own floor plan library. This is how it looks. And then I have my colleagues here in, I've created a demo organization called ATN KPF for this one. I don't have that many plans in here. It's probably enough though for now. But when we partner with architecture firms, we usually add plans to their library, and that becomes the foundation where they generate from. And what's so special about the plans in Finch then? So let's open a small one just to demonstrate it. This is how a plan looks in Finch. And what's special about it is that you can stretch it a little bit like this. You can see the whole plan moves, everything becomes wider. That might not be how you desire that your architecture should behave. So then you can go in and set constraints. As an example, you can say, I don't want my bathroom to flex because I'm going to use a bathroom module. And I actually don't want this one to stretch either. The corridors, they can stretch, but they cannot get more narrow than they already are. So then I'm going to set that kind of constraint. And the next time we flex the plan a little bit, you can see that the bathrooms stay fixed and the corridors take all the discrepancy. So this is a great way of communicating with the system how you would like your design to behave. And of course, it's not intended to take a 50 square meter apartment to stretch it up to 300 square meters. It's more of a reuse of your designs when wall width change, when sites changed, and so on. And if you design double-loaded corridor projects like this one in the demo, you usually have a lot of these really great floor plans that you already have designed that you would like to reuse in projects, even if the unit mix change a little bit. Okay, but enough about the plan. Let's jump back into the project here. Let's see. So here I am in my project. I have my unit mix in place, and I would like to start to generate some floor plans. And the way it works, let's start with the green ones as an example. I select one of them. I click generate floor plan. I have some different options. I can use Nano Banana, I can scan libraries, but I'm going to use the Finch generate floor plan now. So I simply click that one. I give Finch a couple of seconds to evaluate where do we have the outside, where's the neighboring apartment, where's the corridors, and so on, and I see the results starting to pop in here. They are being presented in 3 categories. I have my own floor plan. Let's click one of them. They are a variation of the data I have in my floor plan library. Then I have my colleagues' plans. Of course, I don't have that many plans in this demo organization. This is also based on those plans. And then I have the Finch generated plans down here. I mean, usually I would say best results is from your own libraries, because that's based on the design you like and the constraints you set up, and it's populated with your furniture and so on. But if you don't have any matches in your own plan library, I think the generated plans from Finch is a great way to get started, just adding them and make them your own and build your library that way. That is how I built a lot of the plans in my library. I've generated it with Finch, and then I've made it my own, tweaked it a little bit to get it exactly how I wanted. But for this particular exercise, I'm going to use a furnished plans from my library already now. Let's assign it. There you go. My first floor plan in this massive project feels great. But of course, I don't want to go around and generate in all of them. For me, it's important that I use the same plan, that it's linked. So when I continue refining my project, I don't have to do it in 200 apartments, that I can do it in a single one of them. So I'm going to head down to my unique units. And as you can see, it's the brown one we started with. So I'm simply going to copy this one. I click Control C. I'm going to select all of the same one. I'm clicking Control V. And as you can see, it's get pasted into all of the units. It got rotated as well. So you can enter it from the corridor and so on. And if I go into it, you can see the plan is used in 18 units. So if I, for example, move my little Eames chair here a little bit, you can see that it updates in all of the units. And that is, of course, very important. And this is the kind of level of detail that we're going to get down to. If I would like to steer the generation even further to specify what I want, I can use my graph rules. I'm going to head over here. Oh, I have a little warning here. I'm just going to remove that one little stump. There you go. This is the graph. You can see all of the rooms are mapped with the graph. This is the foundation of Finch. That is how we can generate things that make sense. So if you have a look at this unit, for example, you can see that all of the spaces are mapped as nodes, and then they put together with the graph. And this is how we make sure that you enter the apartment from the corridor into the hallway, so you don't go from the elevator into the toilet, because that is not how you create architecture. It's usually not. Of course, if you want that, you're free to do it, because you can do anything in Finch. There you go. So let's have a look at the next one. Let's go for the little bit bigger one. And then I would like to set up a graph rule. I'm going to say all of my bedrooms, there you go, needs to be larger than, let's see, 10 square meters. Let's see what happens. And then we fire up the generation again. Let's take these ones. Give it a couple of seconds to start. And I'm starting to get some results down here. Once again, I have my own floor plans. I have the plans in the demo organization, and I have some Finch generated plans down here. And if I turn on the labels, you can see all of the bedrooms are more than 10 square meters. Maybe we can try to find someone that's not. I can open a compliance panel here. Let's see, do we have anyone? Yeah, here's a little bit red. You can see that this bedrooms get a warning. It has 93% accuracy, and that is because it's 9.3 square meters when I said 10. Of course, this is based on my own design, so Finch choose to not, make too big modifications. If I don't wish to see anything that is not fully compliant, I can of course just turn on fully compliant. I don't have to see it. But usually as a designer, I think it's nice to just see it, because sometimes the design might be good, and I know I can fix it just by moving some walls and so on. But I leave that up to you. We also have some other scores here, for example, daylight. And if we open this one evaluates all of the plan based on the different space types, if they need daylight or not. For example, the blue ones here, they need daylight. It's bedrooms, it's great rooms, and so on, while bathroom, hallway, storage does not need daylight. So that is put, further into the unit. And then we have adaptivity, and what that is basically is that how similar it is to your data set. Has it been, manipulated a lot? How similar is the result to the original design that you provided? For example, like this one, this is got a score, a lower score. You can see that the adaptivity is really low. That is because it has probably been generated in a way that doesn't remind you of the original architecture, while this one that has a high score looks much better. So let's use this one, for example. Let's add it here. Let's see, how are we with time? In 30 minutes, Ruben is going to take over with the Revit part. Let's see if we can make, fill the whole project here with apartments. I'm going to do the same thing here. I'm going to copy. I'm going to select all of the similar ones. I'm going to paste it. Oh, did I forget? Copy, paste. Let's see. Maybe I selected the wrong one. Give it a couple of seconds. And as you can see, I mean, here as well, Finch figured out that this will not fit in the corner. I need to mirror this one to fit, and it made it, did it automatically. Of course, this is a corner apartment. Maybe you don't want the bedroom out there. I'll leave that up to you. You could, of course, generate again. Now I prioritize the repetition here. Let's fill these ones as well. Let's use that one. Yeah. I play guitar. This is Flying V. I think it's a really cool guitar. I've added it here in my plan. I mean, we will not go through how you create objects in Finch, but you can create whatever kind of object you want, or upload your Revit or Rhino objects. In my case, I added a guitar here, and I think that's an I think it's an important part of the design process to be able to make it your own, make the things that you're proud of, and make it in your own style, basically. Let's add it. There we go. Let's save it. Let's copy. Let's see this one. Let's find the unique ones again. Paste it. And as you can see, I mean, already now we're starting to get a fairly high, I mean, we've been designing this for an hour. I've been explaining what I'm doing. Already now I have a really nice project with a high level of details and linked plans and so on and so on. So let's move on. Let's fill the unique ones as well. Or maybe we start with the tower. What do we feel like? Let's do these tricky ones down here. Let's use that one. And speaking of furniture, let's add an object. Let's add a dog. There we go. My plans, yeah, I can use this a similar one here. There you go. And as you can see, the doors are going outwards in these ones. Let's change that so they go inwards as well. Let's do like this. Maybe we have to move this one a little bit. There you go. Let's change it in this one as well. Actually, this one, I can see that they are really, really similar. Maybe I could fix the thing here. I'm going to show you a little bit, a little trick here in Finch. You can see that these ones are really, really similar. They're not identical, but I could probably reuse it somehow. Let's see if we can make it work. I'm going to delete this one. I'm going to take this one, I'm going to copy it and paste it over here. As you can see, it did not fit at all, so I'm going to mirror it to make it look exactly like the other one and position it in the right place. There you go. And as you can see, of course, this is the other unit that is tilted in here. But if I go into this one, I have one of my favorite things in Finch. Let's pull this all the way out here. I can click union. What happens when I do that is that it takes this plan and fills this one as well. So now I have the same plan. Maybe this kitchen is a little bit too long. You know, let's do like this. Now I have the same plan in two differently shaped units. So if I update one thing, for example, I added a dog, you can see that it's in both places. So although if it doesn't have the same shape, you can have the same linked plan. And this is a really powerful tool, especially like you work with the advanced project like the UN Studio or Saha project where you have an undulating facade or sloping. Then you can have hundreds of unique units, but actually using the same plan. And that also saves a lot of headache when clients ask you to update some of the plans and so on. Okay, let's just fill the last ones here so we have some nice plans, just so Ruben, when he's going into Revit, has the whole building filled out. There you go. As you can see, I'm using a lot of the plans I've added to this project. Of course, I could not. I could use other plans as well, but I like the fact that they're getting in here in the same style, kind of with the same furnishing and so on. Let's walk our way through it. Or maybe I don't think that fitted that well. Some other ones down here. Some of my old ones. I go for that one. Then we have down here. This is a little bit of a tricky shape. Maybe I'm going to Either, yeah, let's just generate. I was thinking about if I should reuse some of the other plans, but let's see what it comes up with. I think that works pretty well. Something like that, I can live with that. And this is a great way. Let's see here. So here we have a Finch generated plan. Let's see if I actually prefer to put the bedroom in the little corner here. Yeah, let's go for this one. Let's assign it here. And of course, I can go in and furnish it. I'm going to select the bed. This one, let's have a double bed here. That's nice. Let's add some sofa. I like the alphabet sofa. It's Danish design. Although I'm Swedish, I really enjoy Danish design. Let's change this door to a something like this. Put it in the middle. There you go. Closets. Of course, I can keep furniture, but let's keep it like this for now. And then we have the last one over here. This is probably a tricky one. I think this is a good example of where I do not get any results from my own plan library, but I get some suggestion from Finch of how I could furnish this one. I think I preferred this one. Let's add that one. There you go. So that's the podium. We have generated a lot of plans here, furnish it. We can see if we turn this one on. I selected someone with bedrooms. That's because I did not specify that this is not a closed bedroom, so I get a little warning. Maybe change this one to create a new space type called studio. Make it green as well. Whoops. Save it. There you go. Perfect. How come? Maybe update that a little bit. Let's see if we can run that one again. Do I need to? Sorry. Why is this one lingering? Let's see if I can get it to update. I'm just going to refresh the browser. Non studio. There we go. I think I have some update problems. Maybe I need to. I'm just going to make a little hack here, see if it works. Anyhow, I'll get back to. It's because I'm in the classes. Just give me a second if I can figure this one out. There we go. I was in the space classes, so then it takes everything that has to, similar to a bedroom, studio, alcove, and this kind. So now I specified on space types at the bedroom. Of course, I have not updated this one yet. Let's put this one as studio as well. This is the beauty of live demos. There we go. Then I have some small bedrooms in this one. That doesn't bother me that much. I'm aware of it. Let's keep it like that. Okay, there we go. So we've populated this story here. Let's work with the towers and fill the whole project out here. So then the question is, will I start up there or at this story? I think I'm going to start in the tower actually. Let's go into the tower here. And the same thing, let's generate floor plans. Let's start with the big ones. Do we have some nice downs here? I think I'm going to go with this one. I think it's, I mean, that's a preference. I think it's nice with the living room in the corner like this, and then we have two or 3 bedrooms actually like that. I think that's a nice distribution. Just copy paste it out to the other ones. Let's do it same for this one, and then let's fill these ones as well. I think there's a lot of talk about AI and creativity, whether or not it removes it or enhances it. I'll leave that up to you guys to decide. But me personally, I think it's very, you know, inspiring, and I think it's very, it's creativity for me to just, you know, fire it up and kind of curate the project. Let's add this one. I don't feel like this is taking the creativity away. I find something I like. Now, of course, I don't have that much time to go deeper into everything, but of course, I can then fix it, add it, you know, do whatever I want with it. It's up to me as a designer. And I really like the fact that it really speeds up the process, and then you get it into Revit, you can get it out to, I mean, when I started working as an architect, I could, you know, you started a render at the evening and hopefully you got back to something that looked okay in the morning. Now we see all kinds of different AI tools that renders basically, you know, in real time, and it's just I think it's just helps me to be creative. I'll leave it up to you guys, of course, but this I enjoy this. Let's paste the last ones here. There you go. We have our towers as well. The last thing I would like to do before wrapping it up here for Ruben is to fill the whole project. I'm going to copy these towers all the way up. It will probably take a little bit of time here for Finch to calculate all of that. And I'm going to fill the whole project here with floor plans. There we go. And then let's see what we have. 10 minutes left. Okay, let's do one thing before we wrap it up here. Of course, here's a number of tools within Finch. I will not be able to go through all of them today. Oh, I forgot to copy these ones down here. Sorry about that. I'm just going to fill that. But I'm going to show you one more, and that is Archie. That is our little helper, our AI helper that helps you with your project. I'm going to show him in a second here. Just going to paste the last ones. I could actually get Archie to paste these ones as well, but yeah, let's just wrap it up. The last things here. Let's leave them, the technical things over here. Maybe we could fit something if we, let's do like this. I'm going to move this one up here. That's probably a little bit more reasonable. Fit that one. And let's see if we can generate something here as well. There you go. So there you go. we have the whole story filled. That is a lot of apartments. Actually, it is 65 apartments in this particular story. And I can have my diagram here. That's very nice. I mean, now all of the apartments are linked, so I can go in and update things in one, but if I would like to update things in multiples, it can be a little bit not tricky. You know how to do. You do it all the time. You do it manually. You go in, you change something. But I think it would be a good opportunity to show what Archie can do. Archie is our little helper here. So he lives up here. It's a little architecture helper. I'm going to write something. Let's see, what are we going to do? Find all plans at this story with a walk-in closet and change the swing door to a pocket door. I think that makes sense. Let's see. Should we make it more complex? Let's start there. And Archie is something fairly new in Finch. We're working hard to get him to be able to do more and more things. At the moment, he's pretty chatty. He's checking the story now, seeing if there are any plans with walk-in closets. And then it seems like we have one here. And then he's going to in there and see if he can change that to a pocket door. Let's see. In this case, that was probably a pretty bad idea of me since there are no wall there. You can, of course, be very specific with this kind of things. In this one, it works probably much better. You can see. Let's see. These are the doors he's probably going to change. And I mean, this is just very, very nice to be able to tell Archie all kinds of things and then let him, update the project for you. I could be more specific as well. I could say find all of the walk-in closet doors, change it to pocket doors, and align it 100 millimeter from the wall, or go through my full project. All of my doors should be aligned like this and that, and so on. So this is just a really nice way of all of this really tedious, repetitive task to get some help with. And Archie is getting smarter and smarter for each day here in Finch, and I'm really looking forward to see what he can do here in the long run. I think it's almost done. There we go. I'm gonna interrupt him now. There you go. Last thing, let's copy it out to the full building. Let's take this one. Oh, actually, I promised you some bigger apartments as well. One of my favorite moves when working with high-rise is to make sure that the vertical alignment works well, is to simply, just give it a second, take an existing part like this and just move this one into the middle. For example, remove this one, and voila, we have some bigger apartments here. And since we always have our diagrams to help us, we immediately know how big they are and how they will work. Oh, maybe I wanted to keep the big ones. Let's see. What was I thinking now? The other way around. Let's paste them. move this guy over here to the middle. Remove that little dimser. There you go. I think that works nice. Let's see, it's over here. Let's generate some bigger ones here. Let's copy paste this one. I think this is okay. This maybe not my finest work. Let's copy this one out to the rest of the. This is going to be one massive Revit model. And while we are, leave that one. While we let him work, let's copy these ones as well, down to the bottom. While we let him work, I can go out here. Let's to the project overview, open my bundles. Let's see. And as you can see, my unit mix has started to pop in here in the part that I've worked with. It's probably still working on this to get them out. But imagine now that you have a colleague working on this one with other typology, maybe an office building and so on. You can in real time see this updates as you go. So this is a great way of working with big projects together. And since it runs in the browser, I mean it's always live. It's no files that you have to merge or that's not updated or you save with weird names in the middle of the night. Everything is updated instantly. It takes a couple of seconds for him to paste it out in the rest of the building. But as we're waiting for this, you can see the breakdown of the different things here. If I would like to see, for example, where do I have all of my bedrooms, I can single them out like this. I can change from area to quantity, see how many bedrooms. The only thing I have more than bedrooms I can see is storage. I have a lot of storage in my buildings. If I go down to the unit mix, I get that specified. I can see where the unique unit is, how many different plans I use in the project, and they are also colorized very nice like this. I think we can start to wrap this up as soon as it gets pasted out here. It'll take some time. It's a pretty big story.
Yeah, it's really impressive. It's really impressive.
Thank you.
I mean, you've made like 1,000 units probably in in an hour and a half, basically.
There you go.
There you go. Yeah.
So now it's ready for Ruben to crash Revit.
Yeah, I'll bring Ruben in.
Thanks, Ollie.
I feel that you got a big challenge ahead of you here. You got 30 minutes to make that giant Revit model.
Let's see what we can do.
But yeah, really impressive. Guys, I don't know if there's any questions. Shoot them in there. I'm sure most people are just watching at this point, but put any questions in the comments. We're seeing there was a big wow. I think it's really impressive. But yeah, let's see. Let's jump into Revit. I'm kind of I'm kind of very excited to see this.
Yeah, absolutely. So what we're going to show you now is the kind of the final stage in the process. We've taken it from Grasshopper through Rhino, done the conceptual, done the massing, brought it into Finch, and now what we're going to do is kind of sever that connection with Finch and now take something out as a Revit model that we can then take into this kind of more detailed design stage. I know I work here at Finch, but it's also cool always for me to see Jesper actually like doing this stuff for an hour and a half. I mean, I think I always learn stuff every time as well. It's there's lots of impressive stuff showing up. All right, I'm gonna go ahead and share my screen. Also, Jesper, I saw you do something you've never done before, which is be nice about Danish people. So that was an exciting thing for me. Never heard a Swedish person do that before.
Yeah, I'm learning, having worked for a Danish company, I'm learning more about this Swedish-Danish love-hate relationship.
The feud. I love Denmark. I actually went to school to Denmark. It's just over the bridge here. And nothing bad to say. Just an official statement.
Official statement.
I feel it's like a brotherly love kind of thing.
Yeah, indeed, definitely. Okay, I'm here in Finch. This should look familiar. This is a very similar project to what Jesper has just been working on. This is one that I prepared just before we started here today, because the plan is I'm going to show you what we can get out in a Revit model. What I'm not going to do actually is I'm not going to go ahead and download it right here in the call, as we know that these Revit models can sometimes be big, and especially when we have a project with 1,000 units like this. Instead, just going to kind of take a look at the quality that we get out. What kind of granular detail do we get out into Revit? And
I can just add a quick one that Ruben actually did this just before the workshop, so it I don't know, took half an hour for Revit to build it or something like that, but we didn't want to do that live and sit and wait for Revit.
No, I think what we're gonna. Oh, sorry, Ali, go ahead.
I was just gonna throw in, it's like a Blue Peter moment.
Exactly.
Only British people might get that, but like here's one I prepared earlier.
Here's one. I think I've made that reference so many times here at Finch, and it's nice now to hear someone else say it. Okay. Yeah, so we have a project right here. Before we jump into Revit, I just want to show you, if you are following along, if this is your first time using Finch, you can just come up to the Finch logo here, and you can, if you click on User Guide, you can kind of get to this from any point in Finch. It's going to pop up here our guide, and this is where we collect kind of all of our tutorials and videos. And crucially for today, what we're going to look at is you can just go ahead and click on Download Plugins, and here download the Revit or the Rhino or the ArchiCAD plugins right here as well. Once we've done that, let's go ahead and let's come into Revit. Okay, don't see much here. So what we're going to do is we're going to go ahead and I'm going to show you now the process of how do we bring a model in? How do we import all this work that we've done and get a Revit model out? So we're going to go ahead and fire up our Finch plugin. And now what I'm going to have to try really, really hard to do once we've looked through the plugin and all the mapping, try really hard to not click import BIM. I've got real muscle memory about that. So let's, Jesper, if you see me hovering towards it, just shout, please. Okay, first thing I'm going to do is I'm going to just change my organization here. I'm then going to go ahead and navigate to my project. And here, if you have multiple variants, like it's been set up, perhaps we've got many buildings here, but we just want to bring in one of them into this project here, so you can choose from your variant dropdown. And then we navigate down here, and we have a few options. Here we have the massing, so this is where we can upload volumes for the first time. We can also upload walls like we did through Rhino. So we can also kind of stay in the entire workflow here in Revit. I'm going to go ahead and click on import BIM. Now, don't worry, this isn't the thing that I said I wouldn't do. This is just going to pull up my little import BIM window for me. Because here we get a few options. First, let's say in this one variant we have multiple buildings, because we can do this, we don't need to always separate them off. Here I can choose which building I'd like to import. And if I want to go into even more detail, maybe I actually just want to bring in a certain floor here as well. I can choose from the list here. Then I'm going to go ahead and click on import settings, and this is where it gets really exciting, I think. And this is because we're now going to take all of the information in Finch, be it walls, doors, furniture, even tags and slabs, and we're now going to go ahead and we're going to go and map these to our Revit families that we have in our Revit templates. I'm sure KPF have a Revit template set up. I'm sure kind of all of you here in the call following along, if you're working for architecture studios, no doubt you have a BIM manager that has built a beautiful Revit template for you. If I go ahead and start my project in that, I can then go and let's start with the exterior wall. I want to map this to my brick 350 mil. I can then go down and look here. Maybe I want some concrete. You know, you can really just go through. And if I click on one where I haven't got anything, then I'm just going to go ahead and create a Finch wall instead. Go in even more detail. And what's really nice is that once we do this, once we've kind of gone through and done all of our mapping, we can go ahead and then just save these settings so that you can then share these with all of your colleagues. So what we're seeing is studios, they create mapping settings for their CLT, their timber construction, maybe for their concrete, maybe for their hybrid, so you can really kind of save out all of these settings as packages. Then go through with all of my doors, furniture, annotation tags, and slabs. With furniture, as Jesper briefly mentioned, through the plugin here, through the Objects tab, you can also send your families up into Finch to populate your object library. This is a really great workflow, I think, because it means that then when we come out to map, if the naming is the same, which it should be if we upload it through Revit, it's just going to land naturally back here in Revit as kind of a 3D family. So I can then go ahead and click on Save Settings. And then I can not click on Import BIM right now, but I'll just go ahead and click on Import BIM and bring in my project. And let's have a look. What happens if I click on Import BIM? Well, if I come over to here, we can take a look at what do we get out. Let's go and actually have a look at this in 3D. So this is a model, and I have done no kind of editing of the geometry right here. This is just kind of mapped directly from Finch out into Revit. How does it come out, you're probably asking? Well, if we go ahead and select any of the units, we can see that first of all, they come out as a model group, and this model group is going to be named however the unit is named in Finch. Within the model group, we can then see we have mapped to these tables. I can see I've mapped to my little kitchen unit here and to my closet and to these beds. And in the cases where I haven't mapped my furniture, it's just come out as a little 2D Eames chair here that you can go ahead and swap out manually if you'd like to. Close out my model group here and let's jump into one of my stories so we can see in even more detail. If I go ahead and select all of these instances in the entire project, we can see we can be able to edit kind of one of these model groups, and that's going to update across the whole tower. As well as all the walls, we also get all these room names, and we also get these room separators. So really what's landing here is now a model which should require as little rework for you as possible. Of course, once I bring in all of this 3D geometry, I then get all the other things that if you're an architect like me, you just love making door schedules. And so now we can have these right here. We can get all the door types with the quantities, the widths, and the heights. Obviously you can go ahead and kind of refine this in as much detail as possible to see kind of as many of the door metrics. Also get space type schedules. And I can then go ahead and just start laying these out on my sheets like so. I'm going to go ahead now and jump over into this project here. And in this project, I've just brought in just one floor. Let me go ahead and pull up my entire floor plan. Because once we've brought our project from Finch into Revit, your time with Finch isn't over if you don't want it to be. We still have some kind of generative tools that we've managed to bring directly into Revit as well. So let's say that we have an example where we've brought in this whole project, we're really happy with it, but then perhaps we need to expand this this little core here. We need to add some kind of MEP shaft or something that needs to run along the side here. And in doing so, this unit that we had here, this just didn't work anymore. So I've had to clear out this unit, and now, well, what are we going to do? Do we want to go back into Finch? Of course we can do that. We can just we can update this, we can update that, we can send this story wall up into Finch. But maybe you just want to stay here and see, have we got anything in our plan library that might be suitable for this unit? To do so, we're going to come up to our plugin again, and this time I'm going to click on Generate, and I'm going to click on Generate Plan. From here, I'm just going to click anywhere inside the unit, and then I'm going to click the wall that I'd like my entrance to be. That's the 2 clicks we have to do. We then go on Finish, All right, if we're going to be pedantic, it was 3 clicks. We've done 3 clicks, and we now pull up our plan library directly here in Finch. So once this starts going, this is going to look pretty similar to what we've just been seeing through Jesper's workflow directly in the browser. So up first, I'm going to get any plans from my personal plan library. Underneath, I'm then going to be getting any of my organization plans. And then I'm going to be getting all my Finch generated plans as well. We could, of course, go ahead and maybe we want to specify a little bit further. You know, I want just residential. I only want plans with 1 bathroom, with 1 bedroom. If we're working perhaps with a specific client, we might have a tag assigned to the plans with this client because, you know, we might know they're very specific about the bathrooms that they want us to use. So we can, of course, also filter by those tags as well. I like the look of one of these units here. I'm just going to go ahead. Which one should we choose? Let's choose this one here. I'm just going to click on my unit and give Revit just a second here. Whilst this is going, we talk about other things that we also bring in. Maybe we can see them here in our list, can we? No, oh yeah, maybe we can. We also have area plans, so we have the GFAs and also rentable areas as well. So you'll find these with yeah, model lines as well. Oh, and look, there we go. Whilst I was waffling on, it has landed for us right here. Let's go and take a look at this in 3D. Nice, this has come in as fully editable geometry. We can see that because we already had this family mapped in the project, it's automatically mapped our table for us. And if we had the bed and the bathroom, it would have done the same for us right there. So that's it. This is perhaps not the final stage in your design process, but this is, of course, the next step, perhaps, before we want to go into even more detail. So this was a super quick, I think, view of how we can take everything that Jesper's done, all of this hard work, we can come out to Finch, and with just a click of a few buttons, we can go ahead and import this all like this. I think that was everything from me. Unless, Jesper, there's anything that you'd like to add, I'll go ahead and stop sharing my screen.
Actually, yeah, I was just, it's really cool, really impressive to see. I'd never seen actually before you guys you're sort of in Revit doing it and like it's generating it in Revit. I mean, it's just, it's kind of a bit mind blowing in a way.
I think what we see is we've seen kind of this other workflow where you just have a Revit file with loads of model groups for your apartments, but they're not kind of parametric. They don't adapt to new unit shapes. So I think now being able to like go from the Finch library in Revit is yeah, it's basically just replacing an existing workflow.
Yeah, and adding to that, I think it's one thing that we're working a lot with here at Finch is, I mean, when you're designing a project, it's not a linear process. You do something, you get wiser, you want to change something. So going back and forth between the different software, and just as Ruben mentioned, maybe you don't want to go back to Finch because you've spent a lot of time in your Revit model. I think it's key to be able to just, you know, pull in some magic into Revit and continue with your daily work, basically.
Yeah, I mean, in the space of less than 2 hours, we have like a pretty detailed building. Obviously, you know, I get that it would take a bit of time to import that, but yeah, 2 hours of actual doing stuff, and you have a pretty detailed BIM model. It's crazy. And I was also noticing it was placing rooms as well, right? And a room tag as well.
Exactly. Yeah, so that you can get kind of the room schedules as well. That's what we're looking at just there as well. So see the total bedroom count across this whole project.
Yeah. And of course, the beauty is you can just map this to all of your, you know, KPF standards or whatever firm it is, and it looks like your plans. So, yeah.
Exactly.
Incredible stuff. Let me bring Miguel back on. so we can maybe just do some closing remarks. Guys, I don't know if we have any questions from the audience. I feel people are probably a bit mind blown. It's always 4 hours. We start to lose people a little bit, but it's all recorded so people can come back. But I mean, just recap, we've made a script. So we sort of started from scratch. We made an entire neighborhood of buildings, roads that you can change right now. You know, we then were able to jump into Finch. We populated the entire buildings pretty quickly. I guess the rest would be as quick. And then next thing you know, we're in Revit with like a fully, almost fully detailed model, right? It's so I guess the advantages for you as architects, Mikhail, is like you guys can spend more time iterating and designing and less time producing, right? That's really the value.
Absolutely. And this is what we should aim for. AI shouldn't, AI or technology shouldn't take our job away. It just should make it easier and allow us to work with more precision, allow us to work faster as well. But the whole fun of designing should stay with us. That's the whole beauty of it, right? So I think what we showed you today was actually representing exactly that's what I'm saying.
Yeah, I was just watching. This is exactly how I would see it being used in practice. Is this workflow from A to B to C? Yeah, guys, put in the chat if you guys have any questions. Give the video a like, share it with people so more people can find it. Thank you guys. I don't know if there's anything else you guys want to suggest. If people want to reach out to you guys and maybe ask you some questions, where's the best place to do that? LinkedIn or anything like that?
LinkedIn, Instagram, or yeah, I think that's the best place. Or go to a website, of course. We're doing our best. We get a lot of email, a lot of reach outs and so on. We're doing our best to answer everyone. It's always nice to when people are reaching out. Please keep it short. No AI generated tweet pages.
Yeah, that's a good point.
The same for me, LinkedIn, Instagram, guys. I noticed I already got a couple of messages, so thank you for
There you go. And you'll all be at the summit in some form. So if you come to the summit, you'll meet these guys and can have a beer and talk all day long about the future of AI and if we're doomed or not. But I think this shows this to me is the real use case, right? It's like it's making us more efficient. It's not taking the design away. Well, guys, thank you so much. For those of you listening, we're still on the workshop run. We've still got a couple more to go before the event. We're bringing back next week Zaha workshop. This is in collaboration with Epic Games, Unreal, and Spaceform. And we're essentially going to go through creating modular kit of parts, bringing it into populating into the building with Rhino, Grasshopper, Unreal, and then walking around in Spaceform. It's the one, unfortunately, we had to postpone, but we're bringing it back next week on Wednesday. So if you missed this, we'll be back. And I'm sure we've got a few things still booked in to do with Finch. So we got a few more bits of content we'll be doing with you guys. But guys, thank you so much for joining. I look forward to seeing you both at the conference, and Jesper and Pamela will be doing a talk, and yeah, I'm really looking forward to that.
Thank you so much for having us.
Thanks.
Awesome.
Thanks a lot for having
Cheers,
us.
Ollie.
See you guys in the next one.
Bye-bye now.
Bye-bye.